Good morning, students. Putin, good morning. Satyam. Tell me the audibility and visibility, please. Tell me the audibility and visibility clear. Okay, good. Hello, very good morning to all of you once again. Welcome to PW platform Maha revision gate series. आज का सेशन है ऑपरेटिंग सिस्टम्स पे. I hope you are all doing excellently well. Your preparation is also tremendous, I believe, with good positive momentum. So objective of Maha revision is to basically help you in the final touches of your preparation. Okay? So I don't want to waste much of your time because time is very important at this moment for your preparation. So essentially my objective of today's session, just a second. My objective of today's session is to touch upon very important topics, high yielding topics. Essentially मान लीजिए आप जैसे एग्जाम के लिए फाइनल प्रिपरेशन कर रहे हो, वो मेरा ऑब्जेक्टिव है. In the minimum possible time, I will try to cover up maximum possible things, or during the coverage of topics, I will tell you what are the important topics to focus on. हम discuss भी करेंगे वो important topics, right? और उस दौरान if you have any questions, any doubts, you can put it in the chat box. I will clarify. कोई भी doubt हो कोई भी topic के ऊपर, I will try to clarify it. Yes, very good morning, Chanchal, Kajal, Kumari. Very nice to see you all people again back. बहुत खुशी हो रही है आप लोगों को देखकर, और ये मैं ज़रूर expect कर रहा हूँ कि your preparation is doing very well. Yes, Putin. चलिए. So without wasting much time, I don't want to take a prolonged session. जितना हो सके minimum time में, so that opportunity is given to you to continue your preparation. लेकिन I will focus on important topics, high yielding topics, and then I will also try to take up some doubts also based on those topics. ठीक है? And मैं एक PDF बनाया हूँ, so this PDF will be shared to you. So later on, आप फिर last moment में very quickly this PDF also we can review based on the topics. It contains all important points. ठीक है? Shifu Qadir and Rudra Kumar, DV. So all of you, please welcome PW platform. So I have basically designed, made the PDF based on the same flow, like introduction and background, process management and all that. So very quickly we'll go through introduction and background, जहाँ पे हम बोलते हैं जैसे important जैसा topic है, what is operating system, right? Interface between user and just I will underline the important point. Goals of operating system, ये एक important topic है. I remember as I told earlier, one of the old paper of GATE, there was a question on goals of operating system. ये एक important topic है बच्चों. एक 1 mark का question हो सकता है इसके ऊपर, हो सकता है. Like as I said, operating system varies, computing environment changes, operating system goal changes. जैसा कि personal computing domain के लिए primary goal is convenience, secondary goal is efficiency. लेकिन उसी तरह if you go to real time systems, primary goal become efficiency, reliability, robustness, and secondary goal becomes the other aspect. So usi tarah, so this is one aspect where you can expect some. So easy to use environment. Secondary goal is efficient use of operating system. Then the other goals like modularity, abstraction, ease of debugging. So these are the goals. Secondly, if you come to functions of operating system, as we classify based on the syllabus, functions include process management, memory management, resource allocation, file system, protection and security. These are the functions. फिर उसके बाद next important topic, yes, Sagar Kumar, Raj, very good morning. Tarun Patel, good morning. So next important function is types of operating system. ये भी एक बहुत इंपॉर्टेंट एस्पेक्ट है. Is another important topic. After goals, the next important topic is types. तो जैसा ऑपरेटिंग सिस्टम एवोल्यूशन से, फर्स्ट टाइप ऑफ ऑपरेटिंग सिस्टम इज बैच ऑपरेटिंग सिस्टम. Right? The real concept of operating system came with batch, where you are going to group jobs of similar type on a magnetic tape and then sequentially. So this also implies sequential execution, or आप बोलेंगे uni-programming. Essentially, batch operating system is also uni-programmed. और आपको पता है what is uni-programming. ठीक है? So this is one aspect which you have to remember. Batch processing or uni-programming is a very important aspect of one of the types of primitive type, one of the old operating system. तो इसका main fundamental characteristic ये है कि in the main memory you will have only one program at a time, and batch of jobs of similar type are formed as a batch, and then you keep on processing them sequentially one after another. It will have increased CPU idleness. ये एक point remember करनी है आपको. One of the important drawback of batch operating system is increased CPU idleness. CPU will not be busy most of the time. So therefore, once I have more idleness, I will have decreased throughput. So that is another important aspect of it. ठीक है? ये हो गया batch operating system. फिर उसके बाद ये हम डिटेल में डिस्कस किए विथ रिगार्ड टू मल्टी प्रोग्रामिंग मल्टी टास्किंग ऑपरेटिंग सिस्टम. मुझे ज़्यादा डिटेल में जाना नहीं है. इंपॉर्टेंट पॉइंट्स मैं आपके लिए लिख दिया हूँ. Later point of time, at your own convenience, you can just glance through the points. Important points I will highlight: increased CPU utilization because we have multiple processes present in the system, so that will also increase the throughput. So this is one important aspect. और मैंने कहा था, if you remember in my crash course, multi-programming is of two types. One is non-preemptive, the other is preemptive. तो और हमने कहा था multitasking is the term generally used by Windows family of operating system, and multi-programming is the term generally used by Unix operating system. So preemptive multi-programmed operating system generally is called multitask operating system. ये आपको याद रखनी है. Multitask operating system means preemptive based multi-programmed OS. So this is about multi-programming. ठीक है? फिर रियल टाइम ऑपरेटिंग सिस्टम के बारे में भी कुछ इंपॉर्टेंट पॉइंट्स है. वेल डिफाइंड फिक्स टाइम कंस्ट्रेंट्स. रियल टाइम ऑपरेटिंग सिस्टम विल हैव द कैरेक्टरिस्टिक दैट दे आर टाइम बाउंड. These responses have to be generated in real time. Otherwise, if responses are not generated in real time, system may fail. It will lead to catastrophic loss and destruction. That is the characteristic of real time system. And आपको पता है real time systems are again classified into two types. One is soft real time and the other is hard real time. Soft real times, deadlines are there but not that strict. Hard real time deadlines are there, very tight deadlines. Like missile control system, satellite launching system are hard real time systems. So there was question in I remember one of the gate paper based on real time system. So having familiarity with real time system is also important. उसी तरह अगर ये आप पढ़ें ठीक है, वरना अगर ना भी पढ़ें तो कोई बात नहीं है. डिस्ट्रीब्यूटेड ऑपरेटिंग सिस्टम, this is basically like your networks, computer networks. The operating system that operate in a networking environment is called distributed operating system. इसकी main characteristic रहती है transparency. The existence of resources will be transparent to the user. Transparency is the important property. So this you have to remember with regard to distributed operating system. हाँ, इसके बाद हमने कहा था, if you remember in crash course also we said, what is the hardware or architectural requirement? क्या मुझे कोई लिख के बताएगा चैट बॉक्स में? What is the hardware or architectural requirement for implementation of a typical multi-programmed operating system? क्योंकि हमने कहा था crash course में, I do remember very well, जिस operating system के functionality आप जो पढ़ रहे हैं ये कोर्स में, this is of a multi-programmed operating system. तो मतलब if you want to implement any typical multi-programmed operating system like Unix or Linux or DOS, or sorry, Unix, Linux or Windows, then what is the architectural support or hardware requirement? Come on, boys and girls, कुछ interaction भी होना चाहिए आपसे. So remember and tell me what are the architectural requirements. ये gate question था in one of the earlier paper. So it's it can be asked and also important to remember. Come on. Can you write down in the chat box and tell me what is architectural requirement for implementing a typical multi-programmed operating system like Unix, Linux and Windows? Come on, boys and girls. Do you remember? No? Shifu Qadir, Chanchal, Tarun Patil, Putin. No. Lecture, I will try my level best to keep within 2 hours, not more than that. Because I don't want to waste you much of your time. Chup Jain. Satyam Arya, it is not privileged. It is not exactly privileged. Address translation, correct. Chanchal, you are right, but I want, there are 3 more, total 3 requirements. Hai. What are the other 2? Chanchal, you are saying 1 is correct, address translation. What are the other 2? एक तो बोर्ड पे ही लिखा हुआ है टॉपिक डीएमए, करेक्ट. 3 requirements है. 1 is DMA support from input output devices like secondary storage. Second is address translation from memory systems or memory. And third is dual mode operation, जो यहाँ टॉपिक लिखी हुई है, dual mode from CPU. हमने कहा था every processor needs to support dual mode operation, जो काफी important है. And based on dual mode operation, there were number of questions asked. Every processor, you know, should operate in 2 modes, user mode and kernel mode. So having familiarity between user and kernel mode, differences between user and kernel mode is very, very, very important. कई क्वेश्चंस आ चुके हैं बच्चों इस बारे में. मैंने कुछ क्वेश्चंस PYQ सीरीज में भी डिस्कस किए हैं और कुछ क्वेश्चंस सुपर 30 सीरीज में भी डिस्कस किए हैं. अगर आप वीडियो ना देखे हो तो प्लीज देख लीजिए, उसमें क्वेश्चंस हैं एंड ऑल दिस. So this is very important topic from GATE perspective. This is one of the high yielding topic, HYT, one of the high yielding topic. तो मैं ये चाह रहा हूं कि अगर आपको कुछ भी कंफ्यूजन है इस बारे में पूछ लीजिए. यस तुषार, गुड मॉर्निंग. So user mode is also called non-privileged mode, kernel mode is privileged. Kernel mode generally is also called monitor mode or system mode or protected mode, right? And thirdly, I would say that all user applications run in user mode, all operating system routines, operating system programs run in kernel mode. Generally, this is indicated by a mode bit. If mode bit is 0, then it is kernel mode generally, and mode bit is 1, it is user mode. It can have vice versa also, but generally we follow this trend. Okay? So based on this, we talk about the concept of context switching. Whenever we perform a context switch, then mode shifting is basically involved here. Mode shifting is an inherent operation of context switching. इसके बारे में हमने एक गेट क्वेश्चन PYQ डिस्कस किया था, if you remember very well. तो ये dual mode operation है, ठीक है? So, yeah, important point to remember that a process running in user mode has no access to the hardware and limited access to the machine instruction set, right? So, right, reading the time of day, reading the status of the processor, generating trap, these are all examples of non-privileged instructions. Privileged instructions has complete charge, complete access to the hardware. So, based on that, the next important, very important topic based on that, many questions asked again is concept of system call. System call is a call to operating system for accessing services. Operating system related services. It is a mechanism to basically change the mode from user to kernel mode. हमने crash course में detail में discuss किया how system call is implemented. Right? System call is translated into a software interrupt instruction या बोलेंगे privilege instruction. Execution of that instruction will result in generating a software interrupt. The interrupt will have interrupt service routine. The execution of interrupt service routine will change the mode bit. Then it will look into the dispatch table to get the address of system call. Then system call is executed. So while system call is executing, most important point to remember is that user process will be in block state. Then after the system call is completed, the mode changes back from kernel to user, and then the user process get unblocked. And we continue. So these are summarized discussion with regard to system call implementation. और एक भी एक important point है जिसे आप remember करना है system call implementation में, parameter passing. Let me ask the question. This could be a potential gate question, please. मैं expect कर रहा हूँ कभी भी question आ सकता है parameter passing on system call पर. क्या मुझे लिख कर बताएंगे यहाँ पर What are the different mechanisms of passing parameters to system call? आपको पता है parameter passing concept क्या है? Whenever we make a function call, we pass the parameters. System call is also a function. तो जब आप system call करोगे from user mode to kernel mode, how are parameters passed? Just to tell you, just to inform you, I will tell you that there are 3 approaches of passing parameters to system call. क्या मुझे यहाँ पर कोई लिख के बताएगा what are the 3 approaches of passing parameters to system call? देखेंगे. How many of you are knowledgeable? Come on, Chanchal, Tushar, Ayan, Aisha Chauhan, Raj, Chanchal, Shifu Khadir. Tell me, and be in interactive mode. What are the approaches of passing parameters to system call? System call can be passed with 3 approaches. Parameters can be passed with 3 approaches. No, Shifu Khadir, that is for normal function. हाँ, मैं इसीलिए पूछ रहा हूँ. Pass by value, pass by reference is basically for normal user level functions, not system call. Not system call. What difference है? Yes, Chanchal, you are right. First approach is passing the parameters in registers. Exactly correct. ये एक multiple choice question हो सकता है, MCQ. First is in registers. But registers are limited in number. अगर parameters ज़्यादा हो तो क्या करेंगे हम? You cannot use registers. So what should we do? Tushar Shishodia, it is not correct. Yes, now Shifu Khadir, you are right. You can pass the parameters in memory block in memory, and pass the address of that block in the register. Correct, very correct. Second parameter ये है. Second approach ये है. What is the third approach? Come on. Chanchal, you are right. Third approach is stack. You put it on stack and use stack operations to do that. Excellent. So this could be a potential question from system call. फिर उसके बाद एक case study आप system call के बारे में पढ़ लेंगे, fork system call. So बच्चों, ये मैं चाह रहा हूं कि generally many questions have been asked based on fork और आगे भी आ सकते हैं. So be very clear about how fork system call works. PYQ and Super 30 series में मैंने काफी problems लिए हैं system call की, fork system call के ऊपर. Please go through them and practice. So that is another important topic on system call, fork system call. And apart from that, you also basically try to learn about other system calls like fork, exec, read, write. मैंने एक list दी थी. So based on that list, you can prepare. ठीक है? So this is another area from where you can expect. So about fork system call also, I have given some important points. You can make a note of it. बहुत ज़्यादा important point जो formula है जिसे आपको remember करना है, वो ये है, last point यहाँ पर लिखा है. मैं यहाँ पर लिखा हूँ last point. Please observe. The last point, important point is this. If the program contain n fork system calls, these are important formula. कई questions आ चुके हैं based on this formula. If the number program contain n fork system calls, the number of child processes that get created are 2 power n minus 1. 2 power n minus 1. This is an important formula. ठीक है? ये बहुत important है. Right? ठीक है. चलिए next. ये होगा इंट्रोडक्शन एंड बैकग्राउंड. इतने टॉपिक्स आप पढ़ लीजिए. तो इंट्रोडक्शन एंड बैकग्राउंड में हमने क्या कहा? इंपॉर्टेंट टॉपिक, गोल्स ऑफ ऑपरेटिंग सिस्टम, टाइप्स ऑफ ऑपरेटिंग सिस्टम. ठीक है? फिर उसके बाद आर्किटेक्चरल रिक्वायरमेंट जहां पर डुअल मोड ऑपरेशन, फिर लास्ट में है सिस्टम कॉल्स. ये टॉपिक्स पर आप फोकस कीजिए. दैट विल बी मोर देन सफिशिएंट इनफ फ्रॉम फर्स्ट चैप्टर. अब सेकेंड चैप्टर पे आएंगे हम, प्रोसेस कॉन्सेप्ट्स. इसमें आपको सबसे पहले देखना है डिस्टिंक्शन बिटवीन प्रोग्राम एंड प्रोसेस. देखिए आप, प्रोग्राम वर्सेस प्रोसेस. व्हाट इज प्रोग्राम, व्हाट इज प्रोसेस, ये हमने क्रैश कोर्स में भी वीडियो में डिटेल में डिस्कस किया है. प्रोग्राम इज एन एग्जीक्यूटेबल प्रोग्राम, कंसिस्ट ऑफ इंस्ट्रक्शंस एंड डेटा, एंड प्रोसेस इज इन मेमोरी. Program is passive, process is active. Program is without resources, process is always with resources. इसमें important point आपको ये जो remember करना है, process as an abstract data type. As an abstract data type, process has its definition, will have its representation, will have its operations and attributes. Will have its attributes. इसमें process structure आपको importantly remember करना है, right? Process image जो है, जो यहाँ पर एक शॉर्ट डायग्राम के बेसिस पर मैं आपको बता रहा हूँ, वो है, देखिए आप कोड सेक्शन है, स्टैटिक डेटा है, डायनेमिक डेटा है, रन टाइम स्टैक है, फिर उसके बाद प्रोसेस एट्रीब्यूट्स, वो जो अदर प्रोसेस कंट्रोल ब्लॉक में रहेंगे. राइट? So that is about the process structure. जो एक image आपको मैं बताया था, if you remember in crash course, you will have code section, then you have data section, then you have heap section, and then you have this stack. Heap can grow and stack can grow. ये process structure है which you have to remember as part of process as an abstract data type. Then attributes of the process, as you know very well, are stored in process control block. One of the important attributes of the process, as you know, is process state of the process. During its lifetime, हमने कहा process will be in different states like new, ready, running, block, and terminate. Okay? So that is one. Yes, students, I will just come within 2-3 minutes. There is an important phone call coming. I have to receive it. I'll just join within 2-3 minutes. Okay? Yeah, I'm back. Sorry for keeping you wait. There was some emergency call, right? So we'll continue. The attributes are state of the process. We were talking about the state of the process. The process can be in various states, as we saw: new, ready, running, and block. These are all the states which are there in main memory: new, ready, running, and block. New means it is in the process of getting into memory. Terminate means it is in the process of going or coming out from the main memory to the disk. Apart from that, there will be also suspend state. So combining this, एक diagram मैं यहाँ prepare भी किया हूँ आपके लिए. You can have a look at it. The attributes of the process are kept in PCB. That you know, every process has its own PCB. Process control block is implemented in the main memory. So this is a small diagram. Later on you can refer it. I have new state here: ready, run, terminate, wait, or block. Then I can have the transition. So this is the process state transition diagram of a typical multi-program preemptive operating system. Like Unix, Linux, and DOS, they follow this approach. There were innumerable questions on process state transition diagram. मैंने वो questions detail में किया था, right? मैंने question detail में किया था, PYQ series and Super 30 series. You can have a look at it. Many questions were asked. So my dear students, boys and girls, be very comfortable with process state transition diagram. काफी questions आ चुके हैं previous gate में. 2022 में भी there was a question on process state transition diagram. So having an extreme knowledge with regard to process state transition diagram is very important. So therefore this is high yielding topic. HYT is high yielding topic. यहाँ से questions जरूर आ सकते हैं PYQs में. This is another area from process state process concepts. Next, schedulers and dispatcher. ये भी बहुत important है. As we know, there are three schedulers: long-term scheduler, short-term scheduler, medium-term scheduler. Three schedulers. आज थोड़े questions पूछ लूँगा मैं यहाँ पर, just to be in interactive mode. Long-term scheduler is responsible for loading of new program from disk to main memory. Short-term scheduler operates on ready queue selection of a process to schedule on CPU whenever CPU is idle. Medium-term scheduler is also called swapper because it is responsible for suspending and resuming the processes. ठीक है, ये है medium-term scheduler की responsibility. And finally, एक मॉड्यूल के बारे में हमने पूछा था, dispatcher. क्या मुझे आप लिख के बताओगे चैट बॉक्स में, what is the role of dispatcher, what is the function of dispatcher? Come on, boys and girls. What is the function of dispatcher? बोलिए. What is the role of dispatcher? What is the function of dispatcher? Dispatcher. Yes, साध की आंख, संध की आंख. I will be available for Gate 2024 also. Shifu Qadri is saying responsible for loading the job into CPU. No, dispatcher. आप technical term बताइए. No, people are not telling. Dispatcher is, yes, Chanchal is right. Carries out context switching. Yes, other person also is right. Ritik Anand. Dispatcher carries out the activity of context switching. Context switching. Which module, please tell me, which module is responsible for controlling degree of multi-programming? One more question. Degree of multi-programming कौन control करता है? Four options: long-term scheduler, short-term scheduler, medium-term scheduler, dispatcher. Who controls degree of multi-programming? Very correct. Many people are telling correctly. Degree of multi-programming is controlled by long-term scheduler. फिर उसके बाद हमने बात की थी ready queue, block queue, suspend queue के बारे में, right? Where these schedulers are going to operate. So these are the concepts with regard to process schedulers. Long-term scheduler है, medium-term scheduler, dispatcher के बारे में भी यहाँ पे डिटेल में मैंने लिखा है. आप बाद में पढ़ सकते हो जो मैंने अभी कहा आपको, right? Short-term scheduler is also called CPU scheduler, जो हमारा next topic होगा. CPU scheduler, right? Because it schedule the processes onto CPU. ठीक है. Next हम बात करेंगे CPU scheduling के ऊपर. Next chapter, जहाँ पे ये again it's a high yielding topic. This is also the whole CPU scheduling is high yielding topic. और बच्चों मैं ये भी आपको बता देना चाह रहा हूँ कि this is a 90% topic. 90% topic का मतलब ये है कि 90% of the gate aspirant will work out problems correctly from CPU scheduling. So इसका मतलब ये है at any cost यू कैनॉट लीव दिस टॉपिक, ये बहुत ज़्यादा इंपॉर्टेंट टॉपिक है, ठीक है। तो इसमें सबसे पहले हम बोलेंगे शेड्यूलिंग क्राइटेरिया क्या है, व्हेन डज शेड्यूलिंग अकर्स, व्हाट इज द नेसेसिटी ऑफ शेड्यूलिंग। शेड्यूलिंग क्राइटेरिया का इनडायरेक्टली मतलब what do you say, scheduling criteria का मतलब ये है कि goals of scheduler, what should be the criteria which are used to compare the different scheduling techniques. Come on, here I'm asking, what will be the goal of short-term scheduler or CPU scheduler? Definitely to maximize the throughput. Schedule the processes in such a way that the CPU is busy most of the time, and that will result in maximization of throughput. Then minimize, come on, minimize what? Come on. Minimize turnaround time, minimize waiting time, minimize response time. अब मैं यहां पर एक सिंपल क्वेश्चन पूछ रहा हूं आपको, जल्दी लिख के बताइए, फॉर्मूलेज फॉर टर्नअराउंड टाइम, वेटिंग टाइम एंड रिस्पॉन्स टाइम. कम ऑन, एटलीस्ट टर्नअराउंड टाइम, वेटिंग टाइम के फॉर्मूलेज लिख के बताइए. शेड्यूल लेंथ का भी फॉर्मूला मुझे लिख के बताइए चैट बॉक्स में, देखेंगे आपको याद है या नहीं है. बिकॉज जितने भी प्रॉब्लम्स प्रीवियस गेट क्वेश्चन में आए हैं, दोज आर ऑल बेस्ड ऑन बेसिकली these formulas. जितने भी प्रॉब्लम पूछे हैं, या तो पूछा गया है टर्न अराउंड टाइम के बारे में, या वेटिंग टाइम के बारे में, या शेड्यूल लेंथ के बारे में, तो आपको फॉर्मूलेज याद होना जरूरी है. एंड आई वांट फॉर्मूलेज इन डिफरेंट केसेस, लाइक नेक्स्ट पेज में मैं लिखूंगा, देखेंगे आप पूरे फॉर्मूलेज बराबर बताते हो या ना हो. सबसे पहले turnaround time of any process Pi is given by completion time minus arrival time, formula 1. Very correct. फिर उसके बाद waiting time of process Pi is given by what? Come on, यहां पर थोड़ा confusion होता है. What is waiting time formula? Satyamara, you are giving waiting time formula for a special case. That is correct, I am not denying. Chanchal, I am not denying that your answer is wrong. But actual formula is like this, remember. Turnaround time minus burst time plus IO burst time. This you have to remember. Satyamara, now you are correct. Yes, ये है formula. IO burst time भी रह सकता है, remember that. Otherwise you will go wrong. हाँ, यहां पर as a special case आप लेंगे. Special case is what? If IO burst time of a process is equal to 0, then waiting time will become turnaround time minus burst time, because IO burst time is 0. ये बात याद रखिए. Third aspect, third special case, if scheduling overhead, please understand, scheduling overhead delta is greater than 0. ये very important point. क्या मुझे अब कोई बताएगा, देखेंगे. These formulas holds if delta is equal to 0, scheduling overhead. If delta is equal to 0. Otherwise, if delta is greater than 0, which is practically the case, then what will be the formula? Very important. What will be the formula for waiting time of process Pi? If delta is greater than 0, let me see how many of you can put the formula correctly. Let me see. This could be a potential question in gate tomorrow in future. If delta is greater than 0, then what will be the formula for? I gave the formula. Putin, you are almost correct. But with a slight mistake. Putin, are you from Russia? Just as a casual side, I'm asking. Are you from Russia or India? Because Putin is the, I hope, president of Russia. Putin name. Okay, Putin is saying yes, he's from Russia, very good. Okay, nice to see you, Putin. Your formula is correct, Putin. एक simple mistake है. I will write down the formula. Boys and girls, please have it. Turnaround time minus burst time plus IO burst time plus C times delta. This is a formula you have to remember. मैं इसे highlight भी कर रहा हूं बच्चों आपके लिए. You have to remember this. C time delta, where what is C? C is nothing but number of times process runs on CPU, it is equal to nothing but number of CPU burst. Number of CPU burst. This formula is important. This formula is important. ठीक है, यही बेसिस पे ये फॉर्मूला आएगा, यही फॉर्मूला के बेसिस पे फिर ये फॉर्मूला आएगा. ये तीन फॉर्मूलेस इस बात, दिस इज कॉल्ड यूनिवर्सल फॉर्मूला है. ये यूनिवर्सल फॉर्मूला, यू वोंट फाइंड दिस इन द टेक्स्ट बुक एंड अदर प्लेस. आई चैलेंज यू, nobody will talk about this, but based on this only you get derived this formula and this formula. If delta is equal to 0, put 0 here, you will get this. If IO burst time is 0, you put IO burst time 0, delta is equal to 0, you get this. Yes, context switch, this context switch overhead. T time delta is context switch overhead, total context switch overhead for the process. Yeah, this is an important formula. फिर last point हम जो discuss करेंगे, response time. Can anybody tell me what is response time? Can anybody tell me what is response time? There was a gate question couple of times on response time. Response time का idea होना चाहिए, और unfortunately मेरी observation है कि many students do not know what is response time. तो यहाँ पर थोड़ा मैं आपको 1-2 मिनट के लिए response time के बारे में बताऊंगा, so that you can have better understanding of response time. Come on, there is no formula. There is no formula for response time. You have to basically devise a formula based on the problem. Problem के basis पर आपको derive करना पड़ेगा, लेकिन एक general definition रह सकता है response time का. What is the definition of response time? First RT, response time minus arrival time. No, Chanchal, it is not like that. Difference between first response and arrival time. Vidhi Mishra, it is not like that. Arrival time का concept नहीं है response time. It is only a special case. I want exact definition of response time. First time process gets CPU minus arrival time of the process. Chanchal, it is not arrival time of process. It is not arrival. Right? I will put the I will say like that, because responses जो होते हैं ना, processes के कई responses रह सकते हैं, कई responses. Generally मैं एक जो full time batch रहता है उसमें एक problem कराता हूँ based on round robin with response time. मतलब ये मान के चलिए आपके process का सिर्फ एक ही response time नहीं हो सकता है. Process may be associated with several requests, and for each request I can have response time. So that is why it is not arrival time. Remember, my next page पर आपको complete definition दूंगा response time का, आप हमेशा वो याद रख के apply कीजिए. Response time RT is nothing but time of admitting the request to the time at which the response का मतलब result, response का मतलब initial result, complete भी नहीं, initial result at which the response is generated. ये है response time का concept. Process may be associated with several requests. तो जो भी टाइम पे, मान लीजिए एक प्रोसेस है, उसके कई रिक्वेस्ट है, ये एक प्रोसेस है, उसका कई रिक्वेस्ट है, दिस रिक्वेस्ट 1, दिस रिक्वेस्ट 2, दिस इज रिक्वेस्ट 3, लाइक दैट. So let's say this time t1 this request is submitted to the time at which जब ये प्रोसेस को चांस मिलेगा सीपीयू पर रन करके रिस्पॉन्स जनरेट करने का, this duration is called response time. Time of admitting the request when it is generated to the time at which the response comes, the first result comes, that is called response time. ठीक है ना? उसका एक सिंपल एग्जांपल जनरली मैं ये देता हूं स्टूडेंट्स को. मान लीजिए आपने अपना वेब ब्राउजर ओपन किया और एड्रेस बार में यू हैव टाइप्ड सम यूआरएल www.amazon.com, लेट अस से. तो टाइम एट विच यू प्रेस एंटर की आफ्टर टाइपिंग amazon.com, that is admitting the request to the time at which Amazon server starts responding and the content of the web page starts displaying, not the whole page has come, start displaying. That is called initial results. So that duration of time is called response time. ठीक है ना? उसका और सेकेंड एग्जाम्पल ये देता हूं. जनरली अगर मान लीजिए ऑफलाइन क्लास है या ऑनलाइन क्लास भी है, मैंने क्लास को कोई एक क्वेश्चन पूछा, आई आस्क्ड वन क्वेश्चन टू द क्लास. The time at which I completed my question, to the time at which some student gave the response. One student started giving the response. That time is called response time. ये है concept response time का. So please remember, there could be questions on response time. ठीक है, ये basis पे आप solve कीजिए, not arrival. हाँ, arrival time may be the for the first request, but not for all requests. Second request, see, this is arrival time of the first request. यहाँ पर है arrival. But this might have come later point of time. So time from time at which request is generated to the time at which its response come. That is called response time. ठीक है ना? Right. Next we proceed. हमने पूरा डिस्कस किया था what is arrival time, burst time, completion time, turnaround time. ये पूरे times के बारे में डिस्कस किए. Then we talk about the different scheduling techniques. अब यहाँ पर हम कोई scheduling technique तो डिस्कस नहीं करेंगे. हाँ, लेकिन मैं एक क्वेश्चन पूछ रहा हूँ, जनरल क्वेश्चन पूछ रहा हूँ पूरी क्लास के लिए. Of all the scheduling techniques जो हमने डिस्कस किए, like for example first come first serve, FCFS, then we discussed about shortest job first, then we discussed about SRTF. These are all the different scheduling techniques that you need to pay attention to. LRTF plus HRRN plus multi-level queue scheduling. इतने scheduling techniques आपको गेट के लिए प्रिपेयर करना है. अब मुझे आप बताइए, यहां पर ये शेड्यूलिंग टेक्निक्स में कोई भी अगर टेक्निक में कुछ डाउट ऐसा हो, नॉट प्रॉब्लम, डाउट अगर हो, कोई चीज समझ में ना आई हो, तो आप मुझसे पूछ सकते हैं, मैं आपको क्लैरिफाई करूंगा. फर्स्ट कम फर्स्ट सर्व, राइट. राउंड रॉबिन नहीं लिखा मैं, राउंड रॉबिन ऑल्सो कम्स, राउंड रॉबिन. ठीक है, अमंग ऑल द शेड्यूलिंग टेक्निक्स यू हैव टू प्रिपेयर फॉर ऑल दिस. सुपर 30 सीरीज में मल्टी लेवल क्यू के ऊपर प्रॉब्लम भी किया हूं मैं, न्यूमेरिकल प्रॉब्लम, और PYQs में काफी प्रॉब्लम्स हम किए शेड्यूलिंग पे. बट माय एडवाइस इज यू हैव टू प्रिपेयर फॉर ऑल. सी HRRN, इफ यू डोंट नो, देन यू हैव टू प्रिपेयर फॉर HRRN. एक शॉर्ट डिस्कशन यहां पर ले लूंगा मैं ऑन HRRN. सो दिस इज FCFS, शॉर्टेस्ट रिमेनिंग टाइम फर्स्ट, एंड देन priority बेस्ड शेड्यूलिंग ऑल्सो यू हैव टू स्टडी. राउंड रॉबिन का कॉन्सेप्ट है ये. हाईएस्ट रिस्पॉन्स, लुक एट दिस. Essentially, highest response ratio. Can anybody tell me what is the basic reason for having HRRN? Viprant Moon, everything I cannot explain in detail. First come first serve is based on arrival time. ठीक है, एक बार quickly हर scheduling technique के selection criteria पे बात कर लेते हुए आगे बढ़ेंगे. First come first serve is based on arrival time. This is non-preemptive, right? It will suffer from a problem called convoy effect. ये है first come first serve के part. शॉर्टेज ऑफ फर्स्ट का क्राइटेरिया क्या है? सिलेक्शन क्राइटेरिया है बर्स्ट टाइम. दिस आल्सो नॉन प्रीएम्प्टिव एंड दिस में लीड टू द प्रॉब्लम ऑफ स्टारवेशन. यही पॉइंट्स डिटेल में लिखे गए हैं यहां पर. यस, नेक्स्ट, शॉर्टेज रिमेनिंग टाइम फर्स्ट, दिस इज आल्सो बेस्ड ऑन बर्स्ट टाइम एंड दिस इज प्रीएम्प्टिव. फिर उसका रिमेनिंग, दिस इज आल्सो बेस्ड ऑन बर्स्ट टाइम and this is also preemptive, except that we are selecting the longest job, right? Priority based scheduling, the selection criteria is based on priority, right? So this will also suffer from the problem of starvation. The drawback of shortest job first, the drawback of shortest remaining time first, longest remaining time first is that it will cause starvation. Second problem, it is non-implementable. But however, you can implement it with predicted burst time. How to predict the burst time, that also we have seen, right? Or you might have studied. So predicting the burst time could be a potential high yielding topic, right? Predicting the burst time. That is priority based scheduling. फिर उसके बाद है round robin. This is a very important topic. Many questions were asked based on this. This is based on arrival time plus time quantum or time slice, and it is inherently preemptive. As such, इसका कोई ड्रॉबैक नहीं है. दिस इज हाईली इंटरैक्टिव और हाईली रेस्पॉन्सिव. राउंड रॉबिन, ये भी आपको सबको पता है, ठीक है. देन बेसिकली लाइक हाईएस्ट रेस्पॉन्स रेशियो ने कई लोग पूछ रहे थे, तो यहां पर बता दूं मैं. तो प्लीज ऑब्जर्व, हाईएस्ट रेस्पॉन्स रेशियो इन शेड्यूलिंग इज टू ओवरकम द प्रॉब्लम ऑफ SJF. दैट इज, इट फेवर्स, इसका इंपॉर्टेंट पॉइंट ये है, फेवर्स नॉट ओनली शॉर्टर प्रोसेसेस, but limit the waiting time of longer process. waiting time of longer process. Look at that. Yes, correct. Chanchal is right. Favors not only आपको favor करना है shorter process, क्यों throughput high होता, लेकिन limit the waiting time of longer process. That is done by using a parameter called response ratio, जिसका formula है waiting time plus service time by burst time. How long the process has waited, right? And then what is the burst time? If waiting time is less, then definitely response ratio will become less. If waiting time is more, response ratio will become more. So it will favor shorter process and favor longer process. एक न्यूमेरिकल एग्जांपल लेकर आप कर सकते हो इसको, राइट? दैट इज HRRN. ठीक है, सम स्टूडेंट्स वेर आस्किंग अबाउट वेर आस्किंग अबाउट फर्स्ट कम फर्स्ट सर्व विद इनपुट आउटपुट. एक सिंपल एग्जांपल लेकर करूंगा, आप लोग यहां पर देख लीजिए. न्यूमेरिकल कर लेंगे हम, ठीक है? मल्टी लेवल इसके बाद कर लेंगे हम. मल्टी लेवल क्यू का कॉन्सेप्ट भी हमने डिस्कस किया. देयर आर मल्टीपल क्यूज, राइट? हियर यू कैन ऐड द कॉन्सेप्ट ऑफ फीडबैक ऑल्सो. This is basically to make sure that the system should have multiple ready queues rather than a single ready queue. ठीक है? So that is about multi-level queue and multi-level feedback queue. फिर उसके बाद एक जनरल डिस्कशन है on CPU scheduling, we can have a look at it. लेकिन उसके पहले जाने से पहले एक सिंपल जैसा एक एग्जाम्पल न्यूमेरिकल प्रॉब्लम हम यहाँ पर देख लेंगे with regard to first come first serve and IO. राउंड रॉबिन से भी कर सकते हो आप. एक छोटा एग्जाम्पल ले लेंगे. बर्स्ट टाइम, IO burst time plus burst time. This is double star topic. IO burst time and burst time ही ले रहा हूं मैं. And for solving it in a simple way, I will take two processes. Arrival time 0, arrival time 1, burst time is 4. Then let's say IO burst time is 10. And then burst time is again 3 units. Burst time is 2, burst time is 5, this is 3. Something like this. मतलब यहां पर यह है, देखिए आप, मतलब यहां पर यह है कि process initially needs to run for 4 units. After completing 4 units of CPU burst time, it needs to perform IO operation for 10 units. After 10 units of IO operation is over, then it needs to perform 3 units of computation on CPU again, then terminate. ये life cycle है, and we assume the scheduling overhead delta is equal to 1 unit. This is important, delta. What is delta? Diagrammatically आपको समझा दूं. This is ready queue. I have some process PR. This CPU. In order for the process to come onto CPU, it take delta by dispatcher. Delta is equal to 1 unit. Dispatcher needs some time. This is called CPU scheduling overhead, not IO overhead. CPU scheduling overhead. That's it. Yes, I will discuss memory management also. All the topics till file system. Don't worry. पूरा discuss करूंगा मैं. I will just give you 2 minutes of time. 2 minutes of time. Let me see. For this data set, I will give you the opportunity to you to work out. इसका workout करके मुझे बताइए. What will be schedule length L? What will be average turnaround time? And what is average waiting time? And what is percentage CPU idleness? Come on, boys and girls, work out. ज़्यादा टाइम नहीं लगेगा. सिर्फ 2 से 3 मिनट में आप ये प्रॉब्लम कर सकते हो. मैं यहां पर टाइम दे रहा हूं. प्लीज वर्कआउट एंड टेल मी व्हाट इज द वैल्यू ऑफ दिस. आई विल गिव यू 2-3 minutes of time. Come on, boys and girls, please start. Work out this problem. I hope you are doing. Come on, Chanchal, Raj, Rudra Kumari, Shifu Khadir, Tanuja, Ubaidur Rahman, work out. First come, first serve. This you have to work with FCFS. Already we told. यहाँ लिखा नहीं, लेकिन you have to work out. You can work out with FCFS. If you get schedule length correct, you will get all answers correct. That is the point. Schedule length बहुत important है. So focus on schedule length always. "21, Putin says, okay, Raj is also saying 21, very good. Everybody is saying 21, schedule length. Okay. Okay. Many people are saying 21, very good, very good. चलिए start करेंगे. This is ready queue. So in ready queue at time 0, we have only P1. So therefore, from ready queue and this CPU, from ready queue, the process will come on to CPU with scheduling overhead delta 1. This is important point, delta 1. Then process P1 runs for 4 units. So starting one from 1, 4 units, 1 plus 4, 5. ठीक है ना? At time 1, at time between 1 and 5, at time 2, process P2 join the queue. You have to put P2 here. Then after that, boys and girls, please see, P1 will go for IO operation. P1 will go for IO operation. How much? 10 units. So starting from 5, 10 units. Matlab, it is going to finish its IO at time 15. It is going to finish its IO at time 15. Okay? But meanwhile, this multi-programming, matlab P2 will take the charge, but with delta 6. So P2 runs. How long? 2 units. 6 plus 2, 8. I assume concurrent IO. Concurrent IO matlab multiple IO devices. Every processor will have, right, multiple IO devices. So now P2 will start its IO operation. For how long? 5 units. So starting from 8, 5 units means 13. Now you observe. So both P1 and P2 are busy performing IO. ठीक है ना? Both are busy performing IO. I don't have any process in ready queue. I have only 2 processes. They are busy performing IO operation. So what will be the state of CPU? Idle. Till what time? From 8 onwards till idle. Till what time? Till some process complete IO. ये दोनों processes में IO complete पहले कौन कर रहा है? P2 complete कर रहा है at time 13. मतलब from 8 to 13 the processor is idle. 8 to 13 CPU is idle. Correct. So at time 13 P2 comes into ready queue. Now this is no overhead. There is no overhead. Otherwise if I take overhead that will become very difficult. So I am taking only overhead as coming from ready queue to CPU. That's it. Okay. At time 13. Then P2 take the charge with delta. Don't forget delta 14. Then P2 take the charge. Needs to run for 3 units. 14 plus 3, 17. P2 completes. P2 is over. P2 is over. Meanwhile, between 14 and 17 at time 15, P1 already completed IO. So P1 will take the charge next, delta 18. P1 needs how much time? 3 units. 18 plus 3, 21. So those who said 21, absolutely correct. This is the Gantt chart, and I'm very sure many people might have prepared the Gantt chart like this. So this is the way you have to work out the diagram. Yes, Putin, you are right. You have to work out like this. This is the concept. If you gear up to this level, I'm very sure you can work out the problems correctly. So from here you can calculate schedule length, you can calculate turnaround time, you can calculate waiting time based on the formulas I give. I don't want to go into that, right? यहाँ पे आप calculate कर सकते हैं. Very correct. So in our regular batches we are taking such problems and tackling with them. Okay, so that is the point. ठीक है. Up next, a quick discussion we will make on multi-threading. So what is threads and what is multi-threading? Also, you know it. Thread is a lightweight process. It is a part of process, right? So the major objective of thread is for providing resource sharing. That is address space. Address space. Thread is a part of process. Each process may have multiple threads. Each thread will have the common address space, common data portion, global data and heap data. and then each thread will have its own separate register set and stack. हर थ्रेड की अपनी ओन स्टैक रहेगी, अपना ओन रजिस्टर सेट रहेगा, लेकिन ग्लोबल वेरिएबल्स, हीप सेक्शन, डेटा सेक्शन विल बी शेयर्ड अमंग ऑल द थ्रेड्स. जितने भी आईपीसी मैकेनिज्म रहेंगे, पाइप्स एक्सेट्रा विल आल्सो बी शेयर्ड. Synchronization mechanism like semaphore monitors will also be shared. So that is about thread. The benefits of threads: improved responsiveness, faster context switching, effective utilization of multiprocessor systems, enhanced throughput, computational speed up, economy and effective resource sharing. ये काफी benefits, ये बहुत important है. All these points are important with regard to benefits of multi-threading or goals of multi-threading. ठीक है? Diagram भी शायद आपने देखा होगा. So based on the number of threads we have, there are two types of threads: single thread process or multi-thread process. Single thread process is your traditional process. Now based on the levels, we have user level threads and kernel level threads. Threads that are created, managed at the user level without using any support of operating system are called user level threads. Threads that are created and managed at the kernel level, they are called kernel level threads. यूजर लेवल थ्रेड्स के ऊपर, कर्नल लेवल थ्रेड्स के ऊपर काफी क्वेश्चंस आ चुके हैं. यूजर लेवल थ्रेड्स आर ट्रांसपेरेंट टू ऑपरेटिंग सिस्टम कर्नल प्लस फास्टेस्ट कॉन्टेक्स्ट स्विचिंग. ये इसके दो इंपॉर्टेंट प्रॉपर्टीज है यूजर लेवल थ्रेड्स. कर्नल लेवल थ्रेड्स, आई मीन द मेन ड्रॉबैक ऑफ यूजर लेवल थ्रेड, जिसकी वजह से आपको कर्नल लेवल थ्रेड में जाना पड़ेगा, द मेन ड्रॉबैक इज बिकॉज ऑफ दिस ट्रांसपेरेंसी. If I need any IO operation or execute any system call, it will result in blocking of the entire process. Blocking of entire process. That is the drawback of user level threads. To overcome that, we have to go for kernel level threads. बस threads के बारे में इससे ज़्यादा और कुछ important नहीं है. यहाँ पे एक टेबल मैंने बताया है, आप बाद में इसके देख सकते हैं. All the details with regard to user level threads and kernel level threads. ये काफ़ी अच्छा important है. ये मॉडल्स और लाइब्रेरीज के बारे में उतना आपको जानने की जरूरत नहीं है. सो इफ यू कॉन्सेंट्रेट ऑन व्हाट इज अ थ्रेड, स्ट्रक्चर ऑफ थ्रेड, डिफरेंस बिटवीन प्रोसेस एंड थ्रेड, एंड देन टाइप्स ऑफ थ्रेड्स, यूजर एंड कर्नल लेवल थ्रेड्स, इतना काफी है फ्रॉम योर एग्जामिनेशन पर्सपेक्टिव. और थोड़े क्वेश्चंस विच आई डिस्कस्ड इन PYQ एंड ऑल्सो सुपर 30 सीरीज, आप उसमें से देख लीजिए, प्रैक्टिस कर लीजिए. दैट आई एम वेरी श्योर वुड बी सफिशिएंट इनफ. अब रही बात, मेजर इंपॉर्टेंट चैप्टर जो हमारा है वो है सिंक्रोनाइजेशन. मेजर टॉपिक सिंक्रोनाइजेशन. चलिए स्टेप बाय स्टेप हम आगे बढ़ेंगे सिंक्रोनाइजेशन में. सबसे पहले व्हाट इज सिंक्रोनाइजेशन? टू अंडरस्टैंड सिंक्रोनाइजेशन हमें सबसे पहले अंडरस्टैंड करना पड़ेगा IPC, इंटर प्रोसेस कम्युनिकेशन. इन दिस रिगार्ड वी जनरली से दैट देयर आर टू टाइप्स ऑफ प्रोसेसेस: इंडिपेंडेंट प्रोसेस एंड कम्युनिकेटिंग प्रोसेस, और कोऑपरेटिंग प्रोसेस और कोऑर्डिनेटिंग प्रोसेसेस. इंडिपेंडेंट प्रोसेसेस का मतलब यह है कि सच प्रोसेसेस डू नॉट शेयर एनी रिसोर्सेस. सच प्रोसेसेस विल हैव बेसिकली लाइक they are independent, they don't coordinate, they don't cooperate, they don't share resources, independent. लेकिन जब भी प्रोसेसेस को कम्युनिकेट करना होगा, जब भी प्रोसेसेस को कोऑर्डिनेट करना होगा, आई नीड शेयर्ड रिसोर्सेस, राइट? आई नीड shared resources. So IPC के लिए the first requirement is resources should be shared. If there is no shared resource, I cannot communicate. I cannot communicate. So that is the primary requirement. लेकिन जब processes share करते हैं resources, then we may encounter some problems. So that is my first question. मैं शायद crash course में भी discuss किया था. In general हम बोलते हैं whenever processes communicate, if they are communicating and not synchronized, that means lack of synchronization अगर हो between communicating processes may potentially lead to some problems. Invariably क्या मुझे आप बताओगे what are the problems that generally arise due to lack of synchronization? जैसा कोई भी communication environment हो, जैसा एक offline class ले रहे हैं, faculty है, students है, student need to get sync with faculty needs to get with the synchronization with students. So now question is, if the communicating processes are not synchronized with each other, then that may lead to potentially 3 important problems. सबसे पहला important problem है inconsistency. Inconsistency ना हो तो data loss हो सकता है. फिर finally एक major problem जो arise होता है generally IPC environment में, वो हम बोलते हैं deadlocks. So all these problems, if you observe, they are not desirable, they are not tolerable. So therefore we need synchronization mechanisms in IPC environment to make sure that there is never inconsistency, data loss or deadlocks. ठीक है, ये बेसिस पर हमने क्लासिफाई किया सिंक्रोनाइजेशन प्रोसेसेस को इनटू टू टाइप्स. वन इज कॉल्ड कोऑपरेटिव प्रोसेसेस, द अदर इज कॉल्ड कम्युनिकेटिंग प्रोसेसेस, इंडिपेंडेंट प्रोसेसेस. ये तो हमने अभी बताया था, राइट? हाँ, इंडिपेंडेंट और कोऑपरेटिव का मैंने डेफिनेशन दिया था. फर्दर आई से सिंक्रोनाइजेशन जो होता है आईपीसी एनवायरनमेंट में, फर्दर दे कैन बी क्लासिफाइड एज कॉम्पिटिटिव प्रोसेसेस और कोऑपरेटिव. Competitive means there is a contention. Processes would like to access the shared resource competitively. There is a variable called C. There are two processes, P1 and P2. Both are trying to update the value of C. That is called competition. Cooperation का मतलब they get affected by each other. जैसा producer consumer problem है, they get affected by each other. That is called cooperation. So whether it is cooperation or competition, processes must be in sync. Processes must be synchronized, otherwise it would lead to problems. So the condition, okay fine, this is all the same thing which I told is given in the points, you can later follow it. Problems arise for not having synchronization, like producer consumer problem यहाँ पर illustration के through बताया गया है, right? These are examples of cooperative synchronization, okay? And this is a program that we are trying to show for producer and consumer, where I am going to show how inconsistency arise. All that is being illustrated in these points. You can read it later, right? So these are not needed. Inconsistency के बारे में भी हम बात किए. Printer spooler demon is another problem where I can prove the problem of loss of data. Printer spooler demon. Later from the slides or later from the PDF you can look at this. अब हम बात करेंगे some terminology की which is essential. So having understood that lack of synchronization may potentially lead to inconsistency, data loss or deadlock. अब हम चाहेंगे कि सिंक्रोनाइज करें प्रोसेसेस को, वो कैसे करें? उससे पहले वी नीड टू बिल्ड अप सम टर्मिनोलॉजी. तो सबसे पहले हम जनरली बात करते हैं, राइट? जनरली बात करते हैं कि व्हाट आर दी नेसेसरी कंडीशंस. ये इंपॉर्टेंट है, नेसेसरी कंडीशंस फॉर सिंक्रोनाइजेशन प्रॉब्लम टू अराइज. हर प्रॉब्लम होने के लिए, फॉर एनी प्रॉब्लम देयर शुड बी सम नेसेसरी कंडीशंस. सो व्हाट आर द नेसेसरी कंडीशंस फॉर द प्रॉब्लम ऑफ सिंक्रोनाइजेशन टू अराइज? One example is one simple example is critical section. One necessary condition is critical section. What is critical section? Critical section is that part of the program text where shared variables are accessed. जैसा producer consumer में updating the value of count or decrementing the value of count, these are critical sections. जब तक critical section ना हो problem नहीं आ सकता. और non critical section is that part of the program where I don't access shared resources. जैसा कि producer consumer में incrementing the value of in. That is non-critical section. मतलब जो भी प्रोसेस आईपीसी एनवायरनमेंट में पार्टिसिपेट कर रहा है वहां पर आपको क्रिटिकल सेक्शन होनी चाहिए, नॉन क्रिटिकल सेक्शन. प्रोग्राम टेक्स्ट will always have two parts, critical and non-critical. Having critical section alone is not sufficient enough. Along with critical section there should be race condition. Race condition का मतलब क्या है? Situation where processes are racing to access critical section. Racing. There must be a race going on. If there is no race, there is no problem. लेकिन रेस कंडीशन होने के बावजूद आपको प्रॉब्लम नहीं आ सकता जब तक आपके पास प्रीएम्पशन ना हो. Yes, that is correct. Chanchal, your answer is correct. So along with race condition, there should be a preemption also. Preemption यहाँ पे मेंशन नहीं किया, आप याद रख लीजिए. There are three conditions. One is critical section, second is race condition. Race condition. Third is preemption. So in any IPC environment, when these three conditions are there, there is a potential liability that always I can get either inconsistency, data loss or deadlock. अगर आप चाह रहे हो कि ये problems ना आए, then what you need is now this problem is defined. This problem is defined as critical section problem. तो ये problem को हम define करते हैं critical section problem से. So now what we need is basically like this is my critical section. Right here are the processes P1, P2, P3, so on. Earlier they were accessing critical section directly. So लेकिन अब हम बोलेंगे यहाँ पर हम बोलेंगे in order to protect this critical section, we required some synchronization mechanism here. We required some synchronization mechanism. ये दोनों को मिलाकर हम बोलेंगे synchronization mechanism. जो हमारा सिक्योरिटी गार्ड है. दिस सेक्शन इज कॉल्ड एंट्री सेक्शन and this section is called exit section. This is our architecture or this is our model of any synchronization tool or synchronization mechanism. जितने भी questions पिछले गेट में आए हैं और आगे भी जो आएंगे और जो टेक्स्ट बुक में है, they will follow this model. So all processes will go through this entry section. One of them will enter and then the entering fellow will come out and intimate to the other waiting processes. Entry section, critical section, exit section. Then when you design any solution, when you design any algorithm or solution, it should satisfy the requirements. क्या मुझे लिखकर बताओगे आप चैट बॉक्स में, what are the requirements of critical section problem? Important topic है. जो questions पूछे जाएंगे यही requirements पर पूछे जाएंगे. There are 3 important requirements. What are the 3 requirements? Come on, boys and girls. Yes. 3 important requirements. Mutual exclusion. First, the principle of mutual exclusion say that if one process is in critical section, other processes should not be allowed. At a time, only one process should be accessing critical section. Second condition is progress. No process running outside the critical section. Fellow who is not interested in critical section should not interfere with those processes that are trying to enter critical section. Should not either prevent them or should not either participate in their decision making. Otherwise, it will lead to indefinite waiting, which is like starvation. That is progress. Third condition is bounded wait. No process has to wait forever to access its critical section. मतलब ऐसा ना हो कि आप सिर्फ कुछ ही processes को allow कर रहे हो critical section में and denying others. There should be a bounded waiting time for other processes to enter critical section. अगर bounded wait condition satisfy ना हुआ, then it will lead to the problem of starvation. Remember, अगर mutual exclusion condition satisfy ना हुआ, तो you may get inconsistency or loss of data. अगर progress condition satisfy ना हुआ, then again you can have like starvation like situation. So these are the 3 requirements. और एक भी एक रिक्वायरमेंट है, जनरली हम ये बोलते हैं कि इट शुड बी आर्किटेक्चरल न्यूट्रल. सॉल्यूशन मैकेनिज्म शुड बी, सिंक्रोनाइजेशन मैकेनिज्म शुड बी आर्किटेक्चरल न्यूट्रल. दैट मींस इट शुड नॉट डिपेंड ऑन द स्पीड और नंबर ऑफ सीपीयू. इट शुड नॉट डिपेंड ऑन द आर्किटेक्चर ऑफ द हार्डवेयर आर्किटेक्चर. तो ये सॉल्यूशंस प्रोवाइड करने के लिए नेक्स्ट पेज पे मैं आऊंगा. ये डेफिनेशन है यहाँ पर, ठीक है. यहाँ पर हम क्लासिफिकेशन बताएंगे. सिंक्रोनाइजेशन मैकेनिज्म द एंटायर क्लासिफिकेशन मैं बताऊंगा और यही बेसिस पर हम जो डिस्कस किए हैं और जो आप पढ़ना है वो यहाँ पर हम देखेंगे. दे आर बेसिकली क्लासिफाइड इनटू 2 टाइप्स. व्हाट आर द 2 टाइप्स? हम बोलेंगे बिजी वेटिंग या ब्लॉकिंग. busy waiting and blocking or non-busy waiting. Further, these two can be sub-categorized as software solution implementable at user mode. Then hardware mechanism, hardware synchronization, then OS based. जो mechanisms आप study करोगे under software category are lock variable. Second है strict alternation. थर्ड है पीटरसन सॉल्यूशन. फोर्थ है डेकर्ट्स एल्गोरिथम. और यही बेसिस पर एक फिफ्थ मैकेनिज्म भी आप चाहो तो पढ़ सकते हो, दैट इज कॉल्ड बेकरी सॉल्यूशन और बेकरी एल्गोरिथम. बेकरी एल्गोरिथम, दीज आर द स्टैंडर्ड वंस. ऑल आर इंपॉर्टेंट प्लीज. मैं चाहूंगा कि आप ये भी पढ़ लीजिए बेकरी एल्गोरिथम फ्रॉम एनी ऑफ द टेक्स्ट बुक लाइक टैननबाउम और इंटरनेट और whatever. Lock variable does not guarantee mutual exclusion, guarantee progress but does not guarantee bounded wait. ये याद रखना है हमेशा. उसी तरह strict alternation, guarantee mutual exclusion, does not guarantee progress, guarantee bounded wait. Orally याद रखना है. Peterson solution, limited to work with 2 processes, may not work with multi-core architectures. guarantees all the three requirements if I work on uniprocessor unicore system, Peterson and Decker's. Bakery algorithm is for multi-process solution. ठीक है? That is about user category. Busy waiting का मतलब यह है they basically keep on polling the entry section and waste time. So general problem जो busy waiting का होता है, it leads to wastage of CPU cycles. और फिर generally busy waiting solution do also suffer from one more problem जिसे हम बोलते हैं priority inversion problem. याद रखिए आप, there are two problems of this. One is wastage of CPU cycles and the other problem is priority inversion may happen with busy waiting solution. ये जनरली होता है जब हम प्रीएम्प्टिव बेस्ड प्रायोरिटी बेस्ड शेड्यूलिंग यूज करते हैं. ठीक है? यस, शिफू खादिर, यू आर राइट. सो दैट इज प्रायोरिटी इन्वर्जन. व्हेन आई यूज इन्वर्टिंग प्रायोरिटीज, हाई एंड लो लेवल प्रायोरिटीज, देन वी गेट दिस प्रॉब्लम कॉल्ड प्रायोरिटी इन्वर्जन. ठीक है? तो उसका सोल्यूशन है to go for priority inheritance protocol and so on. That is about busy waiting. Non-busy waiting solution, blocking solutions. मतलब आइडिया यह है कि CPU अपना टाइम वेस्ट ना करे. I mean processes अपना टाइम CPU पर continuously run करके टाइम वेस्ट ना करे. Test the condition of critical section only once. If it is in use, block. If it is not in use, go to access critical section. That is non-busy waiting. चलिए बच्चों मुझे बता, हाँ उससे पहले हार्डवेयर कैटेगरी. हार्डवेयर कैटेगरी में कौन से सॉल्यूशंस है? फर्स्ट सॉल्यूशन हमने बात की थी TSL. फिर सेकंड सॉल्यूशन है स्वैप. मतलब इसके और कुछ वेरिएशन भी हो सकते हैं. गेट एग्जाम में पूछा गया था क्वेश्चन बाय नेम फेच एंड ऐड. फेच ऐड मतलब यह है कि दीज आर ऑल प्रिविलेज इंस्ट्रक्शंस. Privilege instructions. These are atomic instructions. Using atomic and all these are based on lock variable. They are extension to lock variable. जो basic problem है lock variable का हम यहाँ पर overcome करते हैं synchronization hardware में. Yes, TSL register comma flag, correct. To make a study of all these. They guarantee all the requirements and they are superior to basically the general lock variable solutions. Then third is OS based. OS based. Within OS based, you have to concentrate on three things. One is sleep and wake up. These are system calls. फिर उसका एक extension है, most important topic, semaphores. Two types of semaphores, binary and counting. Very important, star topic, high yielding topic, HYT. बगैर सेमाफोर के जनरली यू शुड नॉट गो फॉर ऑपरेटिंग सिस्टम, राइट, अटेम्प्टिंग ऑपरेटिंग सिस्टम पेपर. Semaphore is that important. What is binary semaphore? What is counting semaphore? Right? And then operations on semaphore. What happens when I perform down operation? What happens when I perform up operation? In counting semaphore, after decrementing the current value, if the value resultant value become negative, that is down, that is block, unsuccessful. Likewise, while incrementing up operation, while incrementing the value of semaphore, if I find that the value of semaphore is negative, then that means there are waiting processes we should wake up. That philosophy you should remember. That is counting and binary semaphores. फिर इसका एक last extension है monitors. तो मेरे slides में शायद I have explanations of all these. So as a shortcut, as a final revision point, you can basically glance through, because I cannot take up individually each one of them and make a discussion here. Okay? But this is a chart, final chart. This is the final taxonomy. ये आपको पूरा पढ़ना है with regard to synchronization. With regard to synchronization, देखिए आप, I have some slides. I have given all important points. ठीक है. So this is the complete solution is given with regard to lock variable. Lock is 0, critical section is free, lock is 1, critical section is in use. How the process is, एक detailed explanation भी दिया गया है with regard to mutual exclusion. फिर strict alternation भी दिया गया है using turn concept. Okay? and important points with regard to strict alternation is given. फिर Peterson's algorithm is explained. My crash course में Peterson algorithm भी explain किया. You can have a look at it. How Peterson algorithm works. Hardware type में जैसा अभी we talked about, we have TSL. Then we have basically like a comparison is given here. Comparison table also is given. You can have a look at it. Like which algorithm meets all the requirements is being shown over here. Then semaphores discussion, types of semaphore. These are the semaphore operations, down and up. You can have a look at it. These are the binary semaphore operations, like that. फिर उसके बाद जो next है topic है जो आपको as an application of semaphore है वो है classical IPC problems. Which one? Tanuja Sahu, which example you want me to explain? Tanuja Sahu. Tell me, I will try if it is possible. Tanuja Sahu, please tell which example you want me to explain. Because explaining one example, one problem is like taking half an hour minimum, I am saying. Tanuja Sahu, if you can tell me clarity, then I will tell. जैसा कि किसी ने कहा FCFS with IO, yes, that's possible, I did it. 3 स्लाइड पहले वाला 1 2 3 बाइनरी, ये तो बाइनरी सेमाफोर है. बाइनरी सेमाफोर में व्हाट एग्जांपल यू वांट? ठीक है, एक सिंपल एग्जांपल लेता हूं, आप वर्कआउट कीजिए क्वेश्चन. लेट्स वर्कआउट ए क्वेश्चन ऑन बाइनरी सेमाफोर. कंसीडर ए बाइनरी सेमाफोर बी सेम. वर्कआउट दिस प्रॉब्लम बॉयज एंड गर्ल्स. इनिशियलाइज टू 1. देन द फॉलोइंग ऑपरेशंस वर कंप्लीटेड ऑन द बाइनरी सेमाफोर. ऑपरेशंस वर कंप्लीटेड. 10p, 3v, 8p, 4v, 6p, 1v. Work out this problem. Question is, what is the final value of semaphore now and what is the size of Q now? Size of Q, block QL. Size of block QL. Come on. Work out this simple question. Generally ये क्वेश्चन पूछा गया गेट एग्जाम में, प्रीवियस गेट एग्जाम में मल्टीपल टाइम्स ऑन काउंटिंग सेमाफोर. अब मैं वही क्वेश्चन बाइनरी सेमाफोर पे रिपीट कर रहा हूं. प्लीज वर्कआउट. साइज ऑफ क्यू इज इंपॉर्टेंट. Okay, what is the value of semaphore? Neha Mishra. Come on, Chanchal, Shifu Khadir. What is the value of semaphore now? Chanchal, you are saying 15. This binary semaphore, not counting. Binary semaphore cannot take minus value. Binary semaphore cannot take minus value. Value of semaphore is high. Shifu Khadir is also saying minus 15. That is wrong. Binary semaphore cannot take negative value. Binary semaphore can take always only 2 values, either 0 or 1. Okay. What is the length of Q? And what is, yes, technical beyond is saying 0. Size Q is 15. What is the value of semaphore? Neha Mishra, no, it is not. Kajal Kumari is saying 16. Different answers. Okay. चलिए वर्कआउट करते हैं. I think there is some confusion with regard to this. Let us work out. Value of semaphore is 1. We are performing 10 down. मतलब first down will be successful, making the value to 0, and remaining 9 processes will get blocked. यहाँ पर मैं block queue बता दूं. This is a block queue. So right now there are 9 processes in the block queue. ऐसे करेंगे हम. So please observe. 3 up operations. So out of 9, 3 processes will get woken up, making the balance to 6. Because there are block processes, value remains 0. So यहाँ पर भी value 0 थी after all this. After this, a value is 0. Now with value 0, 8 down operations are performed. All 8 will get blocked, making the count to 14. ऐसे करेंगे problem. ठीक है? Then now out of 14, 4 will get woken up. 4. Remaining count is 10. Because there are 10 block processes, value will be 0. Next, 6 down operations are performed. So value is 0, 6 down. All 6 will get blocked. Value remains 0. Count will become 16. Then finally what happens? One up operation will wake up one process, making the count to 15, value remains 0, because as long as there are block processes and as long as their process is in critical section, value of semaphore is 0. So final value of semaphore 0, size of the queue is 15. This is correct answer. This is correct answer. So this is the kind of problems on this. Okay? Okay. Next. Then basically we classical IPC problems. यहाँ पर मैं problems तो discuss नहीं करूँगा, definitions भी नहीं बताऊँगा, खाली इतना कहूँगा, all the 3 problems of producer consumer. ठीक है? Then reader writer, types of reader writer problem जो मैं crash course में discuss किया था, if you remember, right? So please focus on that. And then thirdly, focus on dining philosopher problem. All these are important. Particularly implementation of all these using semaphores. Semaphore based implementation is important. There were great questions earlier on this. Semaphore based implementation. Please study that. It is important. ठीक है? यहाँ पे भी कोड यहाँ पर भी है, आप यहाँ से भी कोड स्टडी कर सकते हो बाद में. When you after you get it, readers writers का भी कोड मैंने इंक्लूड किया है, उसी तरह डाइनिंग फिलोसोफर का भी कोड है. So code using semaphore of all the 3 problems are given here. You can make a study of it. Next एक tool है monitor. Monitor basically the collection of procedures, variables and data structures that are all grouped together in a special kind of module or package. Invariably अगर आप monitor को study करना चाहते हो तो मैं ये कहूँगा कि monitor is just like a class. जो ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग में आप पढ़ते हो, इट इज जस्ट लाइक ए क्लास, जहां पर आपके मेंबर फंक्शंस होंगे और मेंबर वेरिएबल्स होंगे, डेटा एनकैप्सुलेटेड इन ए पैकेज. वन ऑफ द इंपॉर्टेंट टॉपिक जो मॉनिटर के बेसिस पर पूछा गया था, वन ऑफ द इंपॉर्टेंट क्वेश्चन वाज मॉनिटर ऑलवेज मेक श्योर दैट इट विल बी फ्री फ्रॉम डेडलॉक. डेडलॉक फ्री रहेगा हमेशा. It always allow only one process to be active in the monitor at a time. उसका generic structure, I don't know whether it is given or not here. इसका एक generic structure ऐसे रहता है, syntax देखिए आप. You define monitor with keyword monitor, then you will have the variable section, condition variables, and these are the methods, these are the procedures. So it is just like a class concept, the concept of class. Its power, computational power is similar to that of what do you say, semaphores, right? So that is about monitor. फिर नेक्स्ट इंपॉर्टेंट टॉपिक जो है जिसके लिए आपको प्रिपेयर करना है, जो हम डिस्कस भी किए क्रैश कोर्स में, राइट, दैट इज अबाउट व्हाट इज, यस, मॉनिटर इज देयर इन द सिलेबस. कंकरेंट प्रोग्रामिंग जिसका नाम है कंकरेंसी. इफ यू रिमेंबर, सी द क्रैश कोर्स, वी हैव डिस्कस्ड अबाउट टाइप्स ऑफ कंकरेंसी. डिटेल में डिस्कस किया क्रैश कोर्स में टाइप्स ऑफ कंकरेंसी. फिर मैंने क्रैश कोर्स में यह भी डिस्कस किया कंकरेंसी कंडीशंस. कौन से कंडीशंस चाहिए? इंटरसेक्शन ऑफ रीड एंड राइट सेट शुड बी 0, नल. इंटरसेक्शन ऑफ राइट एंड राइट शुड बी नल. बर्नस्टीन्स कंकरेंसी कंडीशंस, इस तरह हम डिस्कस किए थे. न्यूमेरिकल प्रॉब्लम भी हम डिस्कस किए थे बेस्ड ऑन कंकरेंसी, इफ यू रिमेंबर, राइट, यूजिंग मैकेनिज्म लाइक पैर बिगिन पैरेंट. यूजिंग मैकेनिज्म लाइक पैर बिगिन पैरेंट. ये काफी क्वेश्चंस आए हैं और PYQ सीरीज में भी मैंने क्वेश्चन डिस्कस किए ऑन कंकरेंसी. So this is also equally important topic. इसमें आप you can solve even questions using semaphores. Using semaphores. ठीक है, एक सिंपल प्रॉब्लम ले लूंगा मैं आपकी अंडरस्टैंडिंग के लिए. चलिए स्टार्ट करते हैं. I will define integer x is equal to 0, y is equal to 25. I will write a concurrent program statement like this. Go begin. X is equal to x plus 1, end. Begin. X is equal to y plus 1, end. जो क्वेश्चंस आए हैं गेट में ये बेसिस पर थे. लेट मी सी हाउ मेनी ऑफ यू विल आंसर क्वेश्चंस करेक्टली. कम ऑन. क्वेश्चन इज फॉर दिस, व्हाट कैन बी द फाइनल पॉसिबल, पूछ रहा हूं मैं, पॉसिबल वैल्यूज of x at the end of the computation. Come on, I'm giving you 2 minutes of time. Solve this question. What can be the final possible values of x at the end of the computation? Come on. What is the answer? Final values of x. If you are in practice, you can answer it orally. There is no need of any computation. Technical Vian is saying 1, 26. Shifu Qadir is saying only 26. Chanchal is saying 1 and 26. Surprisingly, I'm getting wrong answers. Surprisingly, I'm getting wrong answers. I don't know why. That means people are not knowledgeable with this. Vidhi Mishra is saying 27. Neha Mishra is saying 27. Come on, boys and girls. What are कितने possible values होंगे final values of x? ये बताइए please. Nobody is telling the right answer in sequence. Come on. देखिए बच्चों. This is one block. This is another block. You call this as process P1. This as process P2. If you execute, please observe. If you execute first P1 and then P2, ये ऑर्डर हो सकता ना? पहले हम P1 कंप्लीट कर लेंगे, फिर P2 कंप्लीट करेंगे. तो P1 अगर कंप्लीट करेंगे, x की वैल्यू 1 बनेगी, लेकिन x की वैल्यू फिर चेंज होगी 25 + 1 26. अगर हम इस सीक्वेंस में कंप्लीट करें प्रोसेसेस की, तो x की वैल्यू बनेगी 26. और एक भी सीक्वेंस हो सकता है, फर्स्ट आई कंप्लीट P2, देन आई कंप्लीट P1, क्योंकि दोनों कंकरेंट है, राइट? सो P2 अगर कंप्लीट करोगे तो x की वैल्यू बनेगी 26, फिर यहां पर क्या होगा? 26 + 1 27, तो 27 भी बनेगी. 26 भी हो सकता है, 27 भी हो सकता है. जो स्टूडेंट्स कह रहे हैं 1 इज ऑल्सो पॉसिबल, प्लीज टेल मी हाउ 1 इज पॉसिबल. प्लीज टेल मी हाउ 1 इज ऑल्सो पॉसिबल. हाउ कैन द फाइनल वैल्यू ऑफ x be 1? It is possible because this increment is basically having 3 instructions: load, increment and store. Load the value of x into register, increment register and store. So मान लीजिए this is your register R, register. So when I say load, so what get loaded? 0. Increment register, register become 1. लेकिन store होने से पहले अगर preempt कर लेंगे, हम preempt करेंगे, फिर उसके बाद P2 कंप्लीट कर लेंगे. P2 कंप्लीट होने से x की वैल्यू 26 हो जाएगी. फिर उसके बाद फाइनल हम स्टोर करेंगे रजिस्टर इनटू x. सो x की वैल्यू 1 होगी. सो देयरफॉर इफ आई एग्जीक्यूट प्रीएम्प्टिवली लाइक दिस P1, P2, देन P1 कंप्लीटिंग द स्टोर इंस्ट्रक्शन, ये ऑर्डर में, तो फाइनल वैल्यू ऑफ x इज 1. सो दैट मीन देयर आर 3 पॉसिबल वैल्यूज ऑफ x: 1, 26, 27. इस तरीके के क्वेश्चंस प्रीवियस गेट में आ चुके हैं और आगे भी आएंगे. सो यू हैव टू बी एक्सट्रीमली केयरफुल विथ रिगार्ड टू दिस टाइप ऑफ कंकरेंसी में. ठीक है? सो दिस इज ऑल अबाउट कंकरेंसी. फिर उसके बाद हम चले जाएंगे डेडलॉक्स पर. डेडलॉक इज ऑल्सो एन इक्वली इंपॉर्टेंट टॉपिक. यहां पर कॉन्सेप्चुअल क्वेश्चंस, थियोरेटिकल क्वेश्चंस भी इंपॉर्टेंट है और न्यूमेरिकल क्वेश्चंस भी इंपॉर्टेंट है. डेडलॉक का कॉन्सेप्ट क्या है, नेसेसरी कंडीशंस क्या है, ठीक है, फिर स्ट्रैटेजीज. These are all important and this is very very simple to follow. Like system model क्या है, we have processes, we have resources, single instance, multi instance and all that, right? Characteristics क्या है, I mean these are the necessary conditions. Mutual exclusion, hold and wait, no preemption, circular wait, these are the necessary conditions. So this is a conceptual view for a deadlock to happen. And then basically we have 3 strategies: deadlock prevention, deadlock avoidance, deadlock detection and recovery. Prevention का concept ये है कि we are trying to dissatisfy one or more of the necessary conditions. We cannot dissatisfy mutual exclusion. We can dissatisfy hold and wait. We can dissatisfy no preemption and we can dissatisfy circular wait. Tanuja Sahu, I cannot take more example because this is a limited version. If you want to see, you can see PYQ series. Tanuja, I cannot take more. This is not a practicing session. This is a revision course. फिर भी मैं एक प्रॉब्लम लिया हूं है, ठीक है? I'm sorry, you can see the PYQ or you can see Super 30 series video. Okay. Next, we can dissatisfy this. And there are a lot of questions which I solved in PYQ of deadlocks. Please watch that video and see the problems. Conceptual questions on deadlock prevention. फिर उसके बाद हमने बैंकर्स एल्गोरिथम के बारे में भी आपने पढ़ा होगा, उसके बेसिस पर भी काफी क्वेश्चंस आ चुके हैं. प्लीज वर्क आउट दैट. सो आई वुड रिक्वेस्ट PYQs, you please PYQ series, you watch the video, Super 30 series, you watch the video. There are a number of problems that I have solved based on deadlock. So deadlock, you can expect theory questions, reasoning questions, and you can expect numerical questions. ठीक है? Super 30 में भी मैंने solve किया, you can check that. So number of problems we have worked out. So quickly we'll go through here with regard to deadlock avoidance, Banker's algorithm. There are two algorithms here, deadlock safety algorithm. These are the data structures. Available matrix, maximum matrix, allocation, need. A system is said to be safe if the need of all processes can be satisfied in all orders. System is said to be safe. Then resource request algorithm of bankers. Request of any process should be guaranteed if the resulting state is safe. ये है basic idea. मतलब ये है, deadlock avoidance always try to avoid the deadlock by operating the system in safe mode. That's it. Never allow the system to go into unsafe. इस तरीके से करता है. Deadlock is prevented by dissatisfying the necessary condition. Deadlock is avoided by operating the system always in safe mode. Deadlock avoidance and deadlock prevention are more restrictive in nature. Deadlock avoidance is based on a priori information. मतलब हर process एडवांस में बताना चाहिए कि what is its maximum requirement. अगर ना बता रहा हो तो आप ऑपरेट नहीं कर सकते. That is about deadlock avoidance. Then finally detection and recovery. डिटेक्शन के दो एल्गोरिथम्स है, डिटेक्शन फॉर सिंगल इंस्टेंस रिसोर्स, डिटेक्शन फॉर मल्टी इंस्टेंस रिसोर्स. ये रिकवरी के स्ट्रैटेजीज दो है. प्रोसेस टर्मिनेशन, रिसोर्स प्रीएम्पशन. बोथ ऑफ देम विल सफर फ्रॉम द प्रॉब्लम ऑफ स्टार्वेशन. सो दैट इज द बेसिक आइडिया बिहाइंड डेडलॉक. एक सिंपल कॉन्सेप्चुअल क्वेश्चन ले लूंगा यहां पर भी, राइट? हाँ मोहम्मद आसिफ, बैंकर्स एल्गोरिथम पर न्यूमेरिकल ऑलरेडी आ चुके हैं, ऑलरेडी आ चुके हैं दो बार. आई रिमेंबर वेरी वेल. यस अर्पन पॉल, यू आर करेक्ट. printf and scanf both will use system call. Internally library calls may call system call, may use system call, definitely. Yes, ठीक है. तो एक कॉन्सेप्चुअल क्वेश्चन हम ले लेंगे यहां पर विथ रिगार्ड टू डेडलॉक्स. क्वेश्चन इज लाइक दिस, प्लीज सॉल्व. System has n processes. P1 to Pn. There is a single resource R. Single resource R. Each process needs Si copies of R to complete. What is maximum units of R in the system to cause deadlock? Come on, work out this and tell me. A simple conceptual question on deadlock. Work out and tell. देखेंगे कितने लोग करेंगे. बिल्कुल सही विधि मिश्रा. सिंपल कॉन्सेप्चुअल क्वेश्चन on this paradigm or this model. There were many questions asked in earlier papers, many questions asked. So it is like high yielding topic. ये concept आपको आना चाहिए if you really want to solve problems similar to this in the exam. There are n processes, P1, P2, P3, so on, Pn. Every process need copies like S1, S2, S3, so on, Sn. ठीक है? For this process to cause deadlock, I need maximum S1 minus 1. For this to have deadlock, S1 minus S2 minus 1, S3 minus 1, Sn minus 1. This is the maximum condition for a deadlock to happen. No, Chanchal, it is not correct. Check it. What is Pi? It is like this. This is the maximum for deadlock to happen. For deadlock to happen, to cause deadlock. So if you take it, this is nothing but sigma Si minus 1. I is equal to 1 to n, which is nothing but sigma Si I is equal to 1 to n minus n. ठीक है? This is the answer. The answer is this. Sigma Si minus n. Yes. And if you don't want deadlock to happen, what is the minimum to ensure deadlock free operation? Deadlock free के लिए एक minimum कितने होंगे? Deadlock free. Deadlock free के लिए आपको होगा sigma Si minus n plus 1. ये बन जाएगा आपका equation. So for deadlock, without deadlock, this is the basic concept, plus 1. So this is the foundation concept for all such questions. At least 10 to 15 questions were asked on this model in earlier paper. Be very, very clear with this high yielding topic. ये बहुत important है. ठीक है? चलिए अब आगे जाएंगे. सेकेंड मॉड्यूल ऑफ ऑपरेटिंग सिस्टम पे आ जाते हैं, मेमोरी मैनेजमेंट. तो सबसे पहले मेमोरी इज एन इंपॉर्टेंट रिसोर्स. यहां पर मैं आपको चाहूंगा क्रैश कोर्स में, आई डोंट रिमेंबर वेदर वी डिस्कस अबाउट दैट और नॉट, मेमोरी इंटरकनेक्शन टू सीपीयू बहुत इंपॉर्टेंट टॉपिक है. मेमोरी इंटरकनेक्शन टू सीपीयू. क्या आप रैम चिप एंड रोम चिप, हाउ डू यू इंटरकनेक्ट टू द प्रोसेसर एंड हाउ टू कैलकुलेट नंबर ऑफ चिप. कई क्वेश्चंस आ चुके हैं प्रीवियस क्वेश्चन, कैलकुलेटिंग ऑन नंबर ऑफ चिप्स रिक्वायर्ड. नंबर ऑफ चिप्स रिक्वायर्ड. जनरली हर चिप की साइज होती है n by m, नंबर ऑफ वर्ड्स बाय विड्थ ऑफ वर्ड. दिस इज हाउ यू स्पेसिफाई मेमोरी. हाउ मेनी वर्ड्स आर देयर इन मेमोरी एंड हाउ मेनी बिट्स आर देयर इन ईच वर्ड. वर्ड की साइज आप बिट्स में मेजर करोगे या बाइट्स में मेजर करोगे. ठीक है? दिस वन हाई यील्डिंग टॉपिक. Then we talk about logical versus physical address. Logical address is address generated by the CPU and physical address is the address needed to access RAM, to access memory for your instructions and data units. That is physical address. Memory management unit will convert logical address to physical address. Memory management techniques, how are they classified? हमने बात की थी, यहां पर एक फिर आपको taxonomy बता दूंगा. Techniques of managing memory, techniques are divided into two parts: contiguous, non-contiguous. Contiguous is like centralized allocation, हमने बात की थी, and this is like distributed approach. This is like distributed approach. ठीक है? Under contiguous you have techniques like swapping, then you have partitions, and you even have a technique called overlays. Overlays. ठीक है? मतलब the whole process at one place, process may be divided and distributed. Partitions में फिर अगेन दो टेक्निक्स है जिसके बारे में हमने डिस्कस भी किया, फिक्स्ड एंड वेरिएबल पार्टीशंस. डिस्ट्रीब्यूटेड और नॉन कंटिग्यूअस में दो प्राइमरी इंपॉर्टेंट टेक्निक्स है, पेजिंग, सेगमेंटेशन. फिर उसके बाद यू हैव इंटीग्रेटेड अप्रोच, सेगमेंटेड पेजिंग. और फिर नॉन कंटिग्यूअस में एक टेक्निक आप जो डिस्कस करना है वो है वर्चुअल मेमोरी थ्रू डिमांड पेजिंग. बस ये है आपका टोटल आर्किटेक्चर फॉर मेमोरी मैनेजमेंट. इतना आपको पढ़ना है, राइट? इसमें इंपॉर्टेंट है पार्टीशन, फिक्स पार्टीशंस एंड वेरिएबल पार्टीशंस. फिक्स पार्टीशंस में क्या होता है, मेमोरी विल बी डिवाइडेड इनटू फिक्स नंबर ऑफ पार्टीशंस, राइट? लिमिटेड डिग्री ऑफ मल्टी प्रोग्रामिंग. इंटरनल फ्रैगमेंटेशन हो सकता है, फिक्स पार्टीशंस में एक्सटर्नल फ्रैगमेंटेशन नहीं होगा. वेरिएबल पार्टीशन, डायनामिक पार्टीशनिंग, नो इंटरनल फ्रैगमेंटेशन. हाँ, एक्सटर्नल फ्रैगमेंटेशन होगा. टू allocate the process in a partition, in a free area, free hole, we have policies like first fit, best fit, next fit and worst fit. वो बेसिस पर काफी क्वेश्चंस आ चुके हैं. काइंडली प्रिपेयर वेल, दिस इज हाई यील्डिंग टॉपिक. मेनी क्वेश्चंस वर आस्क्ड ऑन दिस. हमने PYQs भी सॉल्व किए ये बेसिस पर. ठीक है, रीजनिंग क्वेश्चंस आ सकते हैं, न्यूमेरिकल क्वेश्चंस आ सकते हैं ये बेसिस पर, तो प्लीज कॉन्सेंट्रेट ऑन दिस। ओवरले इज अ वेरी सिंपल टॉपिक, जहां पर प्रीवियस ईयर में आया था, एक क्वेश्चन आया था ऑन ओवरलेस, तो पे फुल अटेंशन ऑन पार्टीशन। लेकिन अमंग ऑल दिस इज वेरी वेरी इंपॉर्टेंट, पेजिंग एंड सेगमेंटेशन एंड वर्चुअल मेमोरी, ये तीन टॉपिक्स पर आपको काफी फोकस करना है। What is paging? Invariably, paging involves three steps: dividing the address space into pages, chunks or pages, storing the pages in memory frames, physical frames, page frames, and accessing the pages in physical frames to page table. Three steps: dividing the address space into pages, and storing the pages in frames of memory, organizing the pages in frames of memory, and accessing the pages through page table. कई क्वेश्चंस आए हैं बेस्ड ऑन पेजिंग, हमने सॉल्व भी किया इन PYQs, राइट, और सुपर 30 सीरीज में भी, यू कैन कॉन्सेंट्रेट ऑन दैट। लॉजिकल एड्रेस का पेजिंग में फॉर्मेट क्या होता है पता है आपको, इट कंसिस्ट ऑफ टू पार्ट्स, पेज नंबर, ऑफसेट। फिजिकल एड्रेस का फॉर्मेट, ये बेसिस पर आप पूरे क्वेश्चंस वर्कआउट कर सकते हो, फ्रेम नंबर एंड ऑफसेट। ऑफसेट इज कॉमन इन बोथ, तो मतलब ये है कन्वर्टिंग लॉजिकल एड्रेस टू फिजिकल एड्रेस इन पेजिंग इन्वॉल्व्स changing page number to frame number, changing page number to frame number. That's it. That is about paging. Then we have several forms of paging, जिस जो डिपेंड करता है on its performance. अगर टाइम की बात करोगे तो आप TLB यूज करोगे पेजिंग में, अगर स्पेस की बात करोगे तो आप अगर आप स्पेस की बात करोगे तो फिर आप मल्टी लेवल पेजिंग। मल्टी लेवल पेजिंग का बेसिक फंडा यह है, व्हेन द पेज टेबल बिकम लार्ज। देखिए मल्टी लेवल पेजिंग के बारे में बता रहा हूं मैं, आप डायग्रामेटिकली थोड़ा अंडरस्टैंड कर लेंगे। सपोज फॉर एग्जांपल, इफ दिस इज योर वर्चुअल एड्रेस स्पेस, जनरली वी डिवाइड दिस इनटू पेजेस, ठीक है, एंड देन हियर आई हैव फिजिकल एड्रेस स्पेस। You divide this into frames, physical address space. This is P0, this is P1, this is P2, this is P3, and so on. So you store some pages here, P0, P1, P5 in non-contiguous way. To access the pages, you need a page table. This is a page table. पेज टेबल का जनरल आर्किटेक्चर, जनरल फॉर्मूला, यू राइट नंबर ऑफ पेजेस मल्टीप्लाइड बाय एंट्री साइज, दिस इज द फॉर्मूला फॉर पेज टेबल। So this page table will have number of entries equal to number of pages. Number of pages. This entry for page 0, page 1, page 2, page 3, this will contain the frame number. ठीक है? What happens is, if this page table become large, that is one point, it may not fit in one frame of memory. It will not frame. If the frame size is there, it may not frame. It may fit in multiple frames, and it is quite possible that it may fit in different number of frames. So it will not be contiguous. और हम चाहते हैं कि whole page table should be contiguously accessible. लेकिन अगर वो page size से बढ़ गया आपका page table, so you may not be able to store it in one frame and you cannot access it contiguously. So for this reason, one of the approach is applying paging on page table. So multi-level paging, in short, is nothing but applying paging technique on page table. Second reason multi-level paging का ये है, second reason, देखिए आप मान लीजिए, for example I am saying there are 1M pages here, 2.20 pages. लेकिन generally क्या होता है, generally the program may not be using 2.20 1M pages, may not be using. It may be using, for example, 5 to 10 pages. Let us imagine 5 pages. तो देखिए, out of 1M pages, the process is using only 5 pages. और अगर हम ये मान के चलेंगे कि वो 5 pages are maybe 2 pages here, 2 pages here, 1 stack page here like this. तो मतलब out of 1M, it is using only 5 pages. So that means in the page table, I will have only 5 valid entries. 5 valid entries in page table. Because I have to point to those 5 pages. तो बाहर के जितने remaining pages है 1M to 1M minus 5, उतने जो entries है, they are null or empty or blank entries in page table. They are unused entries in page table. मतलब page table में कई entries आपको unused है, you are wasting space. आपको 5 एंट्रीज स्टोर करने के लिए यू आर कंज्यूमिंग 5m एंट्रीज इन द पेज टेबल विच इज गोइंग वेस्ट. So to overcome this problem, we go for multi-level paging. मतलब you are going to take a chunk size. आप determine करोगे एक पेज टेबल में कितने एंट्रीज आप स्टोर कर सकते हो, उतने you take that as a page size for page table and divide this into chunks, into pages. Chunks are called pages here. Divide this. और जितने पेजेस आपको चाहिए, जो 5 एंट्रीज के लिए जो पेजेस चाहिए, उतने ही पेजेस आप मेमोरी में स्टोर कीजिए. And then you can access that through another page table. So for accessing the pages of this page table, I need another page table. तो ये जो पेज टेबल है हम इसे बोलेंगे आउटर पेज टेबल या फर्स्ट लेवल पेज टेबल, और ये जो पेज है, ये जो पेज टेबल है, इसे बोलेंगे इनर पेज टेबल. दिस इज योर एक्चुअल पेज टेबल, दिस इज योर आउटर पेज टेबल. तो यहां पर जो आपके नंबर ऑफ एंट्रीज बनेंगे, that will be equal to number of pages that this outer page inner page table get divided. मान लीजिए ये नंबर ऑफ पेजेस है 100 नंबर ऑफ पेजेस, तो आपके यहां पर सिर्फ 100 एंट्रीज होंगे. अर्लियर यू आर हैविंग 2 power 20 एंट्रीज, नाउ यू विल हैव ओनली 100 एंट्रीज. सो इट गॉट reduced from 2m 1m to just 100 entry page table. So now in the memory you will have this 100 entry page table associated with the process at the first level. फिर उसके बाद जितने भी यहाँ के पेजेस जो जरूरी है वो रहेंगे यहाँ पर. एक समराइज डिस्कशन मैं आपको 2 level पेजिंग का दिया हूँ यहाँ पर. So the basic objective of multi-level paging is to ensure that the outer page table, the main outer page table which the process needs, should be there in one frame of memory, and it should be so that it is contiguously accessible. Second reason is not all pages of the virtual address space are in use by the process. Not all pages, right? So only those pages which are necessary, you store them in memory and access them through outer page table. That's it. That is the concept of multi-level paging. बस इतना डिटेल में, लेकिन जब मैं रेगुलर डिस्कस करता हूँ ये टॉपिक, तो एटलीस्ट आई विल एक्सप्लेन दिस फॉर 3 to 4 hours. लेकिन यहाँ पर इन व्यू ऑफ रिविजन कॉन्सेप्ट वी आर डिस्कसिंग इट. ठीक है. तो मल्टी लेवल पेजिंग के क्वेश्चन भी 1-2 मैंने PYQ सीरीज में भी सॉल्व किया था. यू कैन वर्क आउट. TLB update time is negligible here. Yes, Vidhi Mishra. TLB update time is negligible. See, I mean with TLB the formula will become like this. Effective memory access time with TLB. Hit ratio x into C plus m, 1 level paging. Miss ratio 1 minus x into TLB time plus 2m. TLB sign. ठीक है. So this is the formula which you have to use. This is for 1 level paging. अगर 2 level paging हो तो ये आपको अपग्रेड करना पड़ेगा. C+3m आप C+3m ऐड करेंगे. ठीक है. Along with TLB. If 2 level paging is there, then you have to add C+3m. First level page table access, second level page table access, final access, 3m. It will become like that. Okay? So that is the point. So loading and linking concepts also you can basically go through what is loading, what is linking, address binding. Then we talked about all these techniques. Then paging, these algorithm for paging you can see. We generate the page number, refer into page table, and then we take the frame number, add the offset, you get physical address. Somebody was asking page table size. See, page table size formula is number of pages in the address space multiplied by E. E is page table entry size. Page table entry size in bytes. ये concept. ठीक है. So this is the idea behind it. Page table. Then with TLB, this is the idea which we have also discussed. So just now I told the formula, same thing. TLB access, then for actual page access, then this is the same formula which I gave. Then multi-level paging concept, just now I explained, same thing. And then inverted paging is also one form of paging. This is also used to, the basic core idea of inverted paging is that all processes all processes will use single page table. ये है basic idea behind this. Whereas in traditional paging, every process will have its own page table. Every process will have its own page table. So that is about inverted paging. So a question we have worked out, if you remember in the Super 30 series, I worked out a question on conventional paging and inverted paging. Both of them I have worked out. You can check that question and practice it. फिर उसके बाद then we talked about this is the address translation for inverted paging, then segmentation. The basic core idea behind segmentation is that segmentation preserves user's view of memory allocation. User's view. मैंने crash course में discuss किया था, you can have a look at it. As per user view, we divide our address space, logical or virtual address space, into units called segments. Segments are stored in memory and accessed through segment table. So that is about segmented paging. Then segmented paging can be combined together, right, for overcoming the problem of fragmentation, external fragmentation. We basically use segmented paging to overcome the problem of external fragmentation. So how this can be done? We have solved a question based on this also. देखिए आप segmentation के ऊपर direct question है, there is no problem at all. You can see directly, you can take this question. एक question मैं यहाँ पर ले लेता हूँ segmentation के ऊपर. Please see segmentation. Suppose if I generate segment number 4, address number 4, address offset 100. This is my logical address. So what will be the corresponding physical address from this table? From this table. So please see this. Segment 4, its length is 1000 and you want to access 100th word. So what will be the physical address? Base address 1500, base address 1500 plus offset 100. So therefore 1510. Sorry, 1600. This physical address 1600. So this is segmentation. इस तरीके से आप कर सकते हो. अगर मान लीजिए I generate segment number 1 and 650. This will lead to a trap. Why does it lead to a trap? Because segment 1, its length is 400 and you want to access 650th word. That's not possible. That's not possible. So it will lead to a trap. It will lead to a trap. So that's how the question can be formulated. Then we have virtual memory. The basic idea behind virtual memory is to manage the execution of larger program in small memory area. Nishu Kumar, just now I told, when will it give the error? Manage the execution of larger program in small memory area, and that is implemented through demand paging. We write demand paging in short as DP. Loading the pages on demand at runtime is demand paging. Right? We store the program on disk in the form of pages. Whatever pages are accommodatable, we bring them in memory. And when we generate the address, we try to see whether page is present or not present. If the page is present, page hit. If the page is not present, page miss. Correct? If there is a page miss, page fault, operating system will bring the page into memory through page replacement techniques. P4, LRU, optimal, etc. Okay? So that is the implementation of demand paging. While page replacement, we have to see whether page is modified or not modified. Page is dirty or page is clean. If the page is dirty, I need 2 disk access. If the page is clean, I need 1 disk access. All this is the implementation of virtual memory. Virtual memory implementation in computation of effective memory access time is important. Like for example, if the page hit ratio is 1 minus P, we say memory access time M, page miss ratio P, page fault rate into service time S. Service time may include memory access time. So that is the formula based on which many numericals were asked, and we have solved some questions in PYQ series, Super 30 series. So this is also a high yielding topic, HYT. So far questions, theory questions, reasoning questions were asked based on virtual memory implementation, virtual memory performance. इसका और एक important performance issue है, यहाँ पर हम देखेंगे, शायद है हमारे रेफर में. This is the diagram illustrating the virtual memory concept, जो मैं crash course में भी बताया था. ये performance issue with regard to virtual memory जो अभी मैंने formula describe किया, ठीक है? So this is a formula with regard to what you say TLB. Somebody was asking, so if you have TLB, the formula will become like this for demand paging. formula will become like this for demand paging. ठीक है. फिर पेज रिप्लेसमेंट एल्गोरिथम्स आई डोंट हैव टू वेंचर मच. FIFO है, LIFO है, LRU है, ऑप्टिमल है. इन द बेसिकली PYQ सीरीज एंड क्रैश कोर्स ऑल्सो वी वर्कड आउट प्रॉब्लम. एक जो इंपॉर्टेंट टॉपिक है वर्चुअल मेमोरी का वो है थ्रैशिंग. Many questions were asked in earlier papers based on thrashing. Thrashing is excessive or high paging activity, high page fault rate. System में page fault rate क्यों बढ़ता है? Maybe that happens because of lack of memory, or maybe because of high degree of multi-programming. फिर हम thrashing को control कैसे करेंगे? Thrashing control strategies, right? We have basically like reduce the degree of multi-programming, increase the size of RAM, and then what are the effects of basically like page size contributing to thrashing or page replacement technique contributing to thrashing, all that comes under that. फिर एक लास्ट में जो लास्ट टॉपिक है वर्चुअल मेमोरी की, जनरली स्टूडेंट्स इग्नोर इट, दैट इज नथिंग बट वर्किंग सेट मॉडल. प्लीज आई वुड रिक्वेस्ट, मैं क्रैश कोर्स में भी बताया था, डोंट नेग्लेक्ट दिस वर्किंग सेट मॉडल. वर्किंग सेट मॉडल के बेसिस पर एटलीस्ट 4 to 5 टाइम प्रीवियस क्वेश्चन आए इंक्लूडिंग न्यूमेरिकल इन वन ऑफ द रिसेंट टाइम. So please make a study with regard to working set strategy that helps control thrashing and also utilize memory. That is the beauty of this concept, utilize memory effectively. Utilize memory effectively. That is thrashing, working set model. It control thrashing, it is based on the concept of working set. अब उसके लिए मुझे at least if Qadir, I will need at least half an hour to explain working set strategy. It is based on what do you call working set or principle of locality of reference. Every program is set to obey locality model. Almost every program. So it is based on estimating the size of locality based on the past references which the process has referred. I'm sorry, I mean it will be very difficult because if you are not knowledgeable then it becomes very difficult to explain working set strategy. Yeah, somewhat related to that, COA. Not exactly somewhat, it is somewhat related to network concept of sliding window protocol. Networks में आपने पढ़ा होगा sliding window protocol, उसके जरा सिमिलर है ये वर्किंग सेट स्ट्रैटेजी का अप्रोच. आप वर्किंग सेट साइज डिटरमिन करोगे, उतने फ्रेम्स एक्सेप्ट करोगे और प्रूफ करोगे थियोरेटिकली कि वेदर सिस्टम इज थ्रैशिंग और नॉट थ्रैशिंग. ठीक है, सो दैट इज अबाउट वर्किंग सेट. तो ये पढ़िए आप, बेस्ड ऑन दिस यू कैन स्टडी फ्रॉम गैल्विन. अब लास्ट मॉड्यूल ले लेते हैं रिगार्डिंग फाइल सिस्टम. जो इंपॉर्टेंट टॉपिक्स है, जो इंपॉर्टेंट टॉपिक्स है फाइल सिस्टम में वो है, आई मीन फर्स्ट इंटरफेस पार्ट एंड देन फाइनली द इम्प्लीमेंटेशन ऑफ फाइल सिस्टम. यहाँ पर इंटरफेस के बारे में उतना ज़्यादा इंपॉर्टेंस नहीं है, जैसा कि कॉन्सेप्ट ऑफ फाइल, कॉन्सेप्ट ऑफ डायरेक्टरी, व्हाट आर फाइल एट्रीब्यूट्स एंड देन व्हाट आर डायरेक्टरी स्ट्रक्चर्स, ऑल दैट यू कैन मेक ए जनरल स्टडी. जैसा कि यहाँ पर क्विकली हम देखेंगे, attributes of file like file name, location, permission, file type, authors and etc. Attributes of the file are kept in a table just like PCB we have a FCB, file control block. ठीक है, file control block. फिर उसी तरह file operations है, like we create the file, open the file, read the file, write to the file, update the file, seek to the file and then close the file, terminate the file or basically delete the file, file attributes. These are the different types of files, text file, PDF file, object file and so on. So this is just a generic definition, general thing. Like I said, these are the operations. Access methods, either you can access the content sequentially or you can access in random fashion. So this is just a review, you don't have to really worry about it. ठीक है, लेकिन यहाँ पर important topic ये है allocation methods, file allocation methods और disallocation methods. 3 इंपॉर्टेंट मेथड जो आपको फोकस करना है एग्जामिनेशन पर्सपेक्टिव से, वो है कंटिग्यूअस, नॉन कंटिग्यूअस जिसका नाम है लिंक्ड एलोकेशन, और थर्ड है इंडेक्स एलोकेशन, जो यहां पर डायग्रामेटिकली बता रहे हैं. कंटिग्यूअस एलोकेशन मींस कंटिग्यूअस ब्लॉक्स आर एलोकेटेड टू द फाइल, ब्लॉक्स ऑफ द डिस्क. सपोज इफ अ फाइल नीड 10 blocks, I would allocate 10 contiguous blocks. Linked allocation may non-contiguously, need not be contiguous. Like I form a linked list of the blocks that are in use by the file. in the case of non-contiguous or linked. Contiguous allocation may suffer from internal fragmentation and external fragmentation. Linked allocation does not suffer from external fragmentation. It will have only internal fragmentation. एक सिंपल 1 मार्क क्वेश्चन पूछूंगा जस्ट टू टेस्ट योर नॉलेज. मैं यहां पर एक नया पेज क्रिएट कर एक सिंपल रीजनिंग क्वेश्चन पूछूंगा, देखेंगे कौन कौन आंसर करता है. इंक्रीजिंग existing file size is more flexible in which of the allocation methods? Which of the allocation methods? बताइए, लिख के बताइए आंसर. Increasing the existing file size is more flexible in which of the allocation methods? 1. Contiguous. 2. Linked. And 3rd, index. बोलिए. Then I can give options. 1, 2. These options can be given. 1 and 2. B. 2, 1, 2, 3. C. 2 and 3. D. Only 2. What will you say? Come on. What will you say for this? Only 2? Yes. Hosh is correct. 2 and 3. Correct answer is this. Contiguous it is not flexible, linked it is flexible, indexed also flexible. Because index is also based on non-contiguous approach, linked allocation. Index is also based on linked allocation. So therefore, butane it is not D, please. 2 and 3. Index also it is flexible. You can add any block wherever it is free. Wherever it is free. So that is how the question can be asked. So contiguous allocation, linked allocation, index allocation, what happens? Every file is associated with index block. Index block will hold the addresses of free blocks. Based on index allocation, you have Unix inode structure. Based on index allocation. This is index concept. Index block holding the addresses of blocks which are in use by the file. That is index concept. Then you have Unix inode implementation, Unix inode structure. Many high yielding topic, HYT, high yielding topic. मैंने PYQ और Super 30 सीरीज में क्वेश्चन सॉल्व किए हैं, वेरी वेरी इंपॉर्टेंट. राइट, डायरेक्ट ब्लॉक्स मैंने वो क्रैश कोर्स में भी डिस्कस किया था. डायरेक्ट ब्लॉक्स, इनडायरेक्ट ब्लॉक, डबल इनडायरेक्ट ब्लॉक. You can be given disk block address and disk block size, and you can be asked maximum file size. This is a formula which you have to use for it. एक सिंपल प्रॉब्लम ले लेते हैं बेस्ड ऑन यूनिक्स inode स्ट्रक्चर. डायरेक्ट स्पेसिफिकेशन दे दूंगा, आप वर्कआउट कीजिए. ठीक है. Assume disk block size is 4 KB. Disk block address is 32 bits, right? And the index inode contain 12 direct plus single indirect plus single double indirect. This is the structure of Unix inode. That's how the question is asked. What is maximum file size? जल्दी करके बताइए please, as a matter of practice. What is the maximum file size? Come on, boys and girls, please work out. What is maximum file size? देखेंगे कितने बच्चे करेक्ट करेंगे एज अ मैटर ऑफ प्रैक्टिस. फोर GB, मोहम्मद आसिफ, ओके. शिफू कादिर, प्यूटिन, निशु कुमार, राजू जैना, Tanuja, please tell me. 4 GB, वेरी करेक्ट, ठीक है। तो 12 डायरेक्ट से आपका साइज कितना बनेगा? 12 इंटू 4 KB प्लस 1 block can hold, see these 4 bytes, 1 block can hold, 1 block, 1 disk block can hold 1K addresses, 1K addresses. So therefore 1K into 4 KB, single indirect. डबल इंडायरेक्ट, डबल इंडायरेक्ट से कितना बनेगा? 1K इंटू 1K इंटू 4KB। तो ये हो गया आपका 4 GB। ये कितना बना? 4 MB। ये कितना बना? 48 KB। बहुत नेग्लिजिबल। 4 MB itself is 0.004 GB. So this is roughly 4.004 GB, which you can approximately take it as 4 GB. That's all. एक और क्वेश्चन ये बेसिस पर मैं आपको पूछूंगा, देखेंगे हाउ मेनी ऑफ यू विल आंसर विद दीज डिस्क स्पेसिफिकेशंस। कम ऑन, विद दीज डिस्क स्पेसिफिकेशन व्हाट इज मैक्सिमम पॉसिबल फाइल साइज? come on boys and girls, what answer this question? Disk block size is 4KB. Disk block address is disk block size is 4KB. Disk block address is 32 bits. What is the maximum possible file size? Come on. What is the answer for this? What is the maximum possible file size? बोलिए। मैक्सिमम फाइल साइज, मैक्सिमम पॉसिबल फाइल साइज कितनी होगी? Always remember, given DBA and DBS, I gave the formula. Maximum possible file size is given by the formula 2 power DBA into DBS. ये formula है. This block address is 32 bits. I can have not more than 2 power 32 blocks. Each block of size 4KB. What is 2 power 32? 4G. 4G into 4KB, it is equal to 16 terabytes. This is my maximum disk size. Maximum disk size is equal to maximum possible file size. So definitely the size of the file can get accommodated onto the disk. ये दो concept बहुत important है. ये दो concept important है. Maximum possible file size, maximum disk size, and then given file size with this. So this concept is totally very important. High yielding topic. All right. चलिए आगे बढ़ेंगे. So this is all about the Unix inode structure जो अभी हमने बात की. फिर next एक important topic है disk free space management. कि what are the algorithm for keeping the disk free space? One is called free list. दो important algorithms है. Second है bitmap. There were simple questions asked based on both these approach, free list and bitmap. आप वो भी स्टडी कीजिए, उसके बेसिस पर जो प्रॉब्लम आया था वो भी आप देख सकते हो. फ्री लिस्ट एंड bitmap. So this is about that problem and this is about the bitmap. अब लास्ट जो टॉपिक है हमारी वो है डिस्क शेड्यूलिंग. वेरी सिंपल टॉपिक. अगेन आई वुड से 90% टॉपिक है ये. 90% of the gate aspirants will work out the problem correctly based on disk free space management. तो जो आपको डिस्क शेड्यूलिंग के बारे में 90% of the gate aspirants will work out the problems correctly. तो इसमें जो टॉपिक्स आपको पढ़नी है वो पूरे डिस्क शेड्यूलिंग टेक्निक्स आपको पढ़नी है, जो मैं यहाँ पे नहीं लूँगा. मैं गेट क्रैश कोर्स में हमने डिटेल में देखे. एंड वी हैव ऑल्सो वर्कड आउट सम प्रॉब्लम्स इन PYQ series. The important is scheduling techniques like FCFS, right? And then we have shortest seek time first, then we have scan, then we have look, then we have circular scan and circular look. ये पूरे के पूरे algorithms important है एक न्यूमेरिकल एग्जाम्पल के साथ आप पूरे प्रॉब्लम्स को रिवाइज कीजिए। बहुत सिंपल टॉपिक है, वैरायटी ऑफ क्वेश्चंस, हर क्वेश्चन बहुत सिंपल है। तो जनरली मैं यही कहता हूं कि 90 to 95% ऑफ गेट एस्पिरेंट्स विल वर्क आउट द प्रॉब्लम्स करेक्टली बेस्ड ऑन दिस शेड्यूलिंग टेक्निक। सो एट एनी कॉस्ट यू कैनॉट बेसिकली इग्नोर दिस शेड्यूलिंग टेक्निक। देखिए आप स्कैन, सर्कुलर लुक है, and then performance depends on the number of requests and so on. This is a comparison I have given between all the disk scheduling techniques. You can just go through them. That is very simple to analyze. तो मेरे पास यही था सब कुछ डिस्कस करने के लिए with regard to the operating system topics in crash mode. This PDF will be shared with you. एक बार आप फिर से पूरा PDF पढ़ लीजिए, right? And that will should be sufficient enough. उसके बाद और कुछ मत कीजिए, only प्रैक्टिस के कुछ क्वेश्चंस अगर करना हो तो वो कर लीजिए। जो टॉपिक्स, जैसा कि किसी ने कहा वर्किंग सेट स्ट्रैटेजी है, तो आप वर्किंग सेट स्ट्रैटेजी एक बार पढ़ लीजिए, फ्रॉम गैल्विन टेक्स्ट बुक पढ़िए या टेनेनबाम से पढ़िए, दैट विल बी सफिशिएंट इनफ। अगर समझ में आ गया तो अच्छा है, ना समझ में आ गया तो कोई बात नहीं, आप छोड़ दीजिए। जस्ट फोकस ऑन दोज टॉपिक्स विच आर वेरी विच यू आर वेरी कंफर्टेबल विथ, एंड देन ट्राई टू compound it. So my objective was to complete this within 2 hours. एक 10 minutes थोड़ा extend हो गया, there is no issue. So I don't want to take much of your time. Please concentrate on your preparation. Don't allow any kind of negativity at this stage particularly. Just focus on all the topics of all the subjects which you have prepared, right? Practicing them, and keep your mind cool and comfortable. Don't make any performance comparison. Right, make a good attempt for GATE 2023, and I sincerely hope that you do very well in the exam. All best wishes to all of you from my side. Thank you very much.